προηγούμενες χρονιές στον διαγωνισμό IYND και είμαστε στην ομάδα που πήρε το χρυσό πανελλήνιο και το χάλκινο στο παγκόσμιο. Είμαστε επίσης μέχρι το υπηρετήριο Κλινιώτη και είμαστε εδώ ως εθνολότεροι σήμερα, τη δεύτερη ημέρα του Hellenic YND, Hellenic Young Naturalists Tournament, το οποίο συνεργάζεται φέτος στα εκπαιδευτήριά μας και είναι η τιμή μας να έχουμε στον χώρο μας ένα τέτοιο διαγωνισμό. Φυσικά, ο Hellenic YND είναι το πρώτο βήμα για να πάει μια ομάδα στο παγκόσμιο διαγωνισμό, τον IYND, International Young Naturalists Tournament, όπως φυσικά γίνεται και κάθε χρόνο. Όπως έτυχε και σε εμάς πέρσι, όπου πήραμε το πρώτο πανελλήνιο βραβείο και έπειτα μας δόθηκε η ευκαιρία, το διαβατήριο δηλαδή, για να ταξιδέψουμε στον παγκόσμιο διαγωνισμό, που ήταν να διοργανωθεί στο Καζακστάν, αλλά δυστυχώς λόγω του κορονοϊού αυτό δεν μπόρεσε να γίνει. Τώρα, να μιλήσουμε λίγο για το πώς γίνεται αυτός ο διαγωνισμός. Κάθε χρόνο στην αρχή της χρονιάς ανεβαίνουν 17 προβλήματα, τα οποία μετά, Βασίλινα, κάθε ομάδα εργάζεται από αυτά από το Σεπτέμβριο μέχρι Οκτώβριο, που παίρνει τη γνωστοποίηση για τον διαγωνισμό, μέχρι και σήμερα που ο διαγωνισμός γίνεται. Δουλεύουν σε αυτά τα προβλήματα, τα οποία συνήθως τους προτείνουν κάποια πειραματική διαδικασία, την οποία εκτελούν και με βάση τη θεωρία που είναι αντίστοιχη των πειραμάτων τους και τα αποτελέσματα που θα βρουν οι ίδιοι, κάνουν μία σύγκριση, κάνουν υποθέσεις, τις οποίες επιβεβαιώνουν και γίνεται ένας αναλυτική διαδικασία μέσω της οποίας από ένα πείραμα και μία θεωρία που υπάρχει μόνο στην βιβλιογραφία μας, καταλήγουμε στο αυτό συμπέρασμα που έχουμε πλέον μπροστά μας. Ναι, φυσικά, όταν γίνεται ο διαγωνισμός, οι ομάδες έχουν την ευκαιρία να παρουσιάσουν τη δουλειά τους σε μορφή PowerPoint, σε μορφή παρουσίασης και έτσι να παίξουν τους τρεις ρόλους. Να πούμε ότι σε κάθε group υπάρχουν τρεις ομάδες, από όλες τις ομάδες που συμμετέχουν, τις χωρίζουμε σε group των τριών, οι οποίες και μετά διαγωνίζονται μεταξύ τους για να παίξουν τους τρεις ρόλους. Ας αναφέρουμε τώρα ποιοι είναι αυτοί οι τρεις ρόλοι, όπως είναι διάσημοι και σε αυτόν τον διαγωνισμό. Ο πρώτος ρόλος είναι ο reporter, ο οποίος είναι αυτός που παρουσιάζει τη δουλειά του, που έχει κάνει τόσο καιρό και έχει δουλέψει πάνω σε ένα συγκεκριμένο πρόβλημα από το 2017 μέχρι να ανεβεί. Όταν τελειώσει η παρουσίαση του reporter, ανεβαίνει ο δεύτερος ρόλος, για τον οποίο θα μιλήσει η Βασίλινα, ο opponent, ο οποίος πρέπει εδώ στο σημείο να σταματήσω και να πω ότι ο διαγωνισμός IYND δεν είναι απλά ένας διαγωνισμός πειραματισμού και παρουσίαση των αποτελεσμάτων μας, είναι ένας διαγωνισμός που συνδυάζει την αγγλική, ρητορική και όλα τα προαναφερθέντα περί φυσικής. Δηλαδή, ο opponent που θα ανέβει ακριβώς μετά τον reporter θα αμφισβητήσει όλη τη δουλειά που έχει κάνει ο reporter, θα αμφισβητήσει την εγκυρότητά της, το πόσο καλό ήταν το πείραμα που διενεργήθηκε και η θεωρία που βρήκανε, έτσι ώστε να υπάρχουν τα πιο άρτια αποτελέσματα που γίνονται. Θα γίνει μια σύγκρουση μεταξύ opponent και reporter, η οποία είναι και πιο ενδιαφέρουσα στον διαγωνισμό και είναι αυτή που όλοι οι συμμετέχοντες και εμείς επιθυμούμε κάθε φορά να βλέπουμε, γιατί είναι πραγματικά αποκορύφωμα. Ο τρίτος ρόλος που σηκώνεται μετά το opposition είναι ο reviewer, ο οποίος είναι κάτι σαν εξωτερικός παρατηρητής που περιγράφει ουσιαστικά και κάνει μια περίληψη όσων έχουν υποθεί από τον opponent και τον reporter και τα παρουσιάζει μετά για να μπορέσουν και μετά ευκολότερα οι κριτές να βγάλουν ένα αποτέλεσμα για τις βαθμολογίες. Έτσι, περνάμε από τον παρουσιαστή σε αυτό που αμφισβητεί και σε αυτό που αμφισβητεί τη δουλειά και των δύο, με αποτέλεσμα να έχουμε όσο καλύτερα γίνεται δεδομένα και μια εργασία η οποία βασίζεται στη θεωρία και στηρίζεται με αποτελέσματα κανονικής πειραματικής διαδικασίας, έχει πλέον ένα υπόβαθρο καλύτερο. Φυσικά οι κριτές είναι κατεξοχήν επιστήμονες και μπορούν να βγάζουν βαθμολογίες με βάση τις παρουσιάσεις που έχουν δει, που αυτό γίνεται ακριβώς μετά το κάθε fight. Οι κριτές βάζουν τις βαθμολογίες για να βγουν μετά τα αποτελέσματα. Και περνάνε οι ομάδες στον ημιτελικό, μετά στον τελικό και έτσι τελειώνει ο Hellenic YND με ακριβώς την ίδια διαδικασία διεξάγεται και ο International Young Naturalists Tournament, που κάθε χρόνο διεξάγεται σε διαφορετική χώρα. Και στον οποίο παίρνουν μέρος οι καλύτερες ομάδες, γι' αυτό και είναι ένα πάρα πολύ ενδεικτικός διαγωνισμός. Αν και καταφέραμε, παραδείγματος χάρη, να αποσπάσουμε το πρώτο βραβείο πέρσι, τα υψηλά στάνταρ του άλλου διαγωνισμού δεν μας άφησαν να περάσουμε το τρίτο βάθρο. Μέχρι εκεί φτάσαμε. Οπότε είναι πραγματικά ένας διαγωνισμός που ανοίγει τόσο τις πύλες και το μυαλό μας όσον αφορά τη φυσική, τη χημεία, σαν επιστήμες και τη βιολογία φυσικά, σαν επιστήμες τις οποίες εμείς μελετούμε και ανακαλύπτουμε μόνοι μας, όσο και τους ορίζοντές μας όσον αφορά το να γνωρίσουμε τον κόσμο. Φυσικά να αναφέρουμε ότι γίνεται και στα αγγλικά ο διαγωνισμός, οπότε τα παιδιά αναπτύσσουν τις δεξιότητες τους και σε αυτό το κομμάτι και είναι και ένα από τα στοιχεία που καθιστούν τον διαγωνισμό και πιο δύσκολο προς τα παιδιά. Σίγουρα. Αυτά και σας ευχαριστούμε όσους ήρθαν εδώ πέρα, τους καθηγητές, τα παιδιά και φυσικά περιμένουμε του χρόνου να σας δούμε στον τέταρτο Hellenic YND, όλους όσους θέλουν να συμμετέχουν.
Στον παγκόσμιο.
Βέβαια.
Αυτό είναι για να μας πιάνει τον ήχο στο διαδίκτυο. Αλλά πρέπει να ακουγόμαστε και εδώ, γιατί χθες δεν ακουγόμαστε. Πιο ψηλά βάλτε, ψηλά.
Ναι. Ναι, απλά ανάβει τέτοια. Ναι, δεν ακούγεται τίποτα.
Το βάλα τώρα.
Ωραία, ευχαριστώ πάρα πολύ.
Διαλογή μου.
Εκεί πέρα έχει κάτι με χαρτί, για δεις λίγο το χαρτί. Πίσω το λάπτοπ.
Μητρήσε. Και μετά θα παρουσιάσω εδώ τις ομάδες. Δημήτρη, πρέπει να πατήσω κάτι εδώ. Ακούγομαι. Ναι. Έχω και από την ψήρα. Ξεκινάμε σε λίγο, παιδιά. Ναι, εντάξει. Ανοίγω και αυτό. Είμαστε έτοιμοι. Πάμε.
Ευχαριστώ. Καλημέρα σας. Καλώς ήρθατε στο τελικό αγώνα του Third Hellenic για Naturalists Tournament 2022. Βρισκόμαστε στη Θεσσαλονίκη, στα εκπαιδευτήρια Φρυγανιώτη, όπου σε λίγο θα παρακολουθήσετε το μεγάλο τελικό του διαγωνισμού. Μαζί μου είναι ο κύριος Απόστολος Μιχαλούδης, μέλος του Διοικητικού Συμβουλίου της Ένωσης Ελλήνων Φυσικών και εκπρόσωπος της Ελλάδας στους διεθνείς διαγωνισμούς IYNT και IYPT.
Καλημέρα σε όλους.
Απόστολε, πώς φάνηκε ο διαγωνισμός μέχρι στιγμής?
Ήταν ένα συναρπαστικό διήμερο με πολύ δυνατές ομάδες και πολύ ωραίους αγώνες. Όλες οι ομάδες γενικά ήταν πολύ κοντά στη βαθμολογία και αυτό έτσι αναδεικνύει και τον διαγωνισμό. Συγχαρητήρια βέβαια και σε όλους. Σήμερα όμως θα έχουμε μόνο 3 ομάδες, οι καλύτερες μετά από όλη αυτή τη διαδικασία, οι οποίες θα είναι και μαζί μας στον μεγάλο τελικό. Έτσι λοιπόν, έχουμε εδώ σήμερα μαζί μας την ομάδα Μαντουλίδης Λαγκράντς, Action Schrödinger Scatch και Ανατόλια Big Bang.
Συγχαρητήρια σε όλες τις ομάδες. Μην ξεχνάμε ότι για να έρθουν στη Θεσσαλονίκη εργάστηκαν σκληρά καθ' όλη τη διάρκεια της σχολικής χρονιάς. Οι Αμερικανοί λένε ότι sometimes you win, sometimes you learn. Για εμάς είναι όλοι νικητές.
Σίγουρα οι Αμερικανοί λένε και κάτι άλλο. First is everything, second is nothing. Οπότε σήμερα εδώ δεν νομίζω κανένας να χαριστεί σε κάποιον άλλον. Να ευχαριστήσουμε και πάλι τα εκπαιδευτήρια Φρυγανιώτη για την υπέροχη φιλοξενία τους. Πραγματικά τα συντόνισαν όλα τέλεια. Δεν δημιουργήθηκε το παραμικρό πρόβλημα. Ευχαριστούμε πολύ τον κύριο Σάκη Φρυγανιώτη, την κυρία Εύη Παρισοπούλου, τους εθελοντές, τους μαθητές και όλους τους άλλους κύριους καθηγητές οι οποίοι εργάστηκαν και βοήθησαν εδώ πέρα στους αγώνες. Λοιπόν. Ξέρουμε ότι αυτός ο διαγωνισμός δεν είναι μόνο ένας διαγωνισμός γνώσεων. Είναι ένας διαγωνισμός ο οποίος καλλιεργεί και δεξιότητες. Επομένως, πέρα από αυτούς οι οποίοι διαγωνίστηκαν όλες αυτές τις μέρες, θέλω να ευχαριστήσω και τη νέα γενιά. Έχουμε μαζί μας σήμερα τη νέα γενιά που εκπαιδεύτηκε αυτό το διήμερο με ένα σεμινάριο πάνω στη διερευνητική μάθηση, πάνω στην επιστημονική μέθοδο. Τους ευχαριστούμε πάρα πολύ που ήρθανε και που μας τίμησαν και ελπίζουμε να τους έχουμε του χρόνου ως διαγωνιζόμενους.
Και φυσικά, μην ξεχνάμε τους εκπαιδευτικούς που εργάστηκαν όλη τη χρονιά για να υποστηρίξουν τις ομάδες και το δύσκολο τους έργο, που είχαν να βγάλουν εις πέρας και που ήταν εδώ μαζί μας ως κριτές.
Στο σημερινό τελικό, η Κριτική Επιτροπή αποτελείται από τους κύριο Χάρη Χριστοφορίδη. Κύριε Χάρη.
Καλημέρα και από μένα. Ονομάζομαι Χάρης Χριστοφορίδης, είμαι καθηγητής βιολογίας στα εκπαιδευτήρια Ράπτου στη Λάρισα. Για μένα οι στήριοι νικητές. Εύχομαι καλή επιτυχία, συγχαρητήρια σε όλους σας και να έχουμε ένα καλό παιχνίδι.
Ευχαριστούμε. Κύριο Σταύρο Λαγωνικάκο.
Καλημέρα και από μένα. Εύχομαι να έχουμε έναν δυνατό τελικό. Πιστεύω όλα τα παιδιά του ευχαριστήθηκαν. Εγώ προσωπικά είμαι φυσικός στα εκπαιδευτήρια Ράπτου και εύχομαι να κερδίσει ο καλύτερος.
Κύριο Απόστολο Νικολάου.
Ήταν μια πρωτόγνωρη εμπειρία για πολλά παιδιά, αλλά και για όλους εμάς που συμμετείχαμε. Καλή επιτυχία στη συνέχεια στις 3 ομάδες που είναι στο τελικό.
Ευχαριστούμε. Κύριο Δημήτρη Πετρίδη.
Καλημέρα και από μένα. Συγχαρητήρια σε όλους όσοι συμμετείχανε. Ελπίζω να το απολαύσατε και καλή επιτυχία στις σημερινές ομάδες.
Κύριο Σταύρο Σαμαρά. Μέλος της Ένωσης Ελλήνων Φυσικών, συγγραφέας σχολικών βιβλίων και βοηθημάτων και των θεμάτων στους πανελλήνιους διαγωνισμούς. Κύριε Σταύρο.
Υπερβάλλει λίγο ο Απόστολος. Λοιπόν, καταρχάς να δώσω συγχαρητήρια σε όλους και μόνο που βρίσκεστε εδώ. Είναι μεγάλο κατόρθωμα και να πω ότι, για να παραφράσω τα λόγια του ποιητή, άξιζε να υπάρχουμε για να βρεθούμε εδώ και να κάνουμε επιστήμη. Ευχαριστώ πολύ.
Κύριο Κώστα Βουριά, ειδικό γραμματέα της Ένωσης Ελλήνων Φυσικών, γενικό γραμματέα της Βαλκανικής Ένωσης Φυσικών, συγγραφέα βιβλίων υπεύθυνων δράσεων της Βόρειας Ελλάδας, λίγα είπα. Κύριε Βουριά.
Λοιπόν, όπως είχα πει την πρώτη μέρα, ο διαγωνισμός είναι εθιστικός. Ξέρω ότι κάποιοι από εσάς μπορεί να είναι λίγο απογοητευμένοι από το αποτέλεσμα, να θέλουν να είναι αυτοί τώρα εδώ πέρα. Ξέρω όμως επίσης ότι μόλις γυρίσετε σπίτι σας θα ξαναδείτε τα προβλήματα, θα τα ξαναμελετήσετε. Εγώ θέλω να σας ευχηθώ όλους καλή επιτυχία στους συμμετέχοντες και κυρίως να μιλάτε δυνατά εδώ πάνω.
Κυρία Αλεξάνδρα Νικολαίδου.
Γεια σας και από μένα. Συγχαρητήρια σε όλα τα παιδιά που συμμετέχουν, και αυτούς που προκρίθηκαν και αυτούς που αποκλείστηκαν. Εύχομαι έναν καλό τελικό και καλά αποτελέσματα.
Κυρία Έφη Μαβίδου.
Καλημέρα. Εύχομαι να τα δώσετε όλα, να περάσετε καλά, το θυμάστε πάντα και να τον αγαπήσετε όπως τον αγαπάμε εμείς αυτόν τον αγώνα.
Κύριο Θωμά Παπατάσο.
Γεια σας και από μένα. Συγχαρητήρια σε όλα τα παιδιά που πέρασαν στο τελικό και εύχομαι να έχουμε έναν καλό αγώνα.
Και κύριο Γιάννη Καλατζή.
Καλημέρα σε όλους. Συγχαρητήρια σε όσους έπαιξαν και σε όσους θα παίξουν σήμερα. Καλή επιτυχία και εσείς που εκπαιδευτήκατε φέτος, ελπίζουμε να σας δούμε του χρόνου.
Πάρτε μικρόφωνο. Πάρτε μικρόφωνο. Και τα δύο. Οι ομάδες θα πρέπει να μιλήσουν, να πάρω τα μικρόφωνα σε λίγο. Ευχαριστούμε πολύ όλους. Χωρίς άλλη καθυστέρηση, ανακηρύσουμε την έναρξη του μεγάλου τελικού. Από εδώ και πέρα, όπως το απαιτούν και οι κανονισμοί, όλοι οι διάλογοι θα γίνονται στα αγγλικά. Αμέσως μετά το τέλος του αγώνα θα ακολουθήσει τελετή βράβευσης για όλες τις ομάδες.
Welcome to the final fight of the 3rd Hellenic Young Naturalists Tournament. 3 teams have made it so far. Each one of them have chosen the problem they wish to present according to the regulations. On the screen, you can see...
Without
the screen. Well, not with the screen, but you can still see the roles of each team for the stage of the fight. The captain of the team, Adelinis Legrand, please stand up and present your team.
Έλα από εδώ. Πήγαινες από εκεί. Έλα εδώ μαζί μου. Και εδώ, να ακούγεσαι και στα δύο. Μίλα δυνατά, μίλα δυνατά.
Hello, my name is Serifovich Nikolas, and I'm the captain of Team Lagrange Matulidis. With me in the team is George Vlachonasios, Tomas Papamazidis, Ευστράτιος Αρτοπιός, Αγγελική Χουσιάδα, and Φωτεινή Παυλίδου. Good luck to all the teams, and I wish you all a good fight.
Thank you very much. Now?
Now I would like for the captain of the team Action Schrödinger's Cats, please stand up and present your team.
Okay, hello everyone. My name is Athanasiada Lacourelle and I'm from Team Action. So I am Athanasiada Lacourelle, as I said. We have Socrates Paras from my team, Corina Kaladzi and Antti Markaki. Thank you.
And now for the captain of the team, Anatolia Big Bang, please stand up and present your team.
Thank you. I am Paris Ioannou, the team leader of Big Bang, and with my team, in my team, I have the honor to have Christina Mavromati, Dimitra Karkapouna, Michalis Kotiris, Vasilis Kosmatopoulos, and Tamas Giannas, and let's have a good fight.
Everything is ready. Please start the clock. Reporter, please come to the stage, and you have 3 minutes to prepare your report. Opponent, please come to the stage. Best luck to all of you. Ένας από εδώ, ένας από εκεί. Καθίστε. Ένας από εδώ, ένας από εκεί. Big Bang, Big Bang. Φλασάκι, φλασάκι. Εκεί, αυτός κάτω. Έλα. Εδώ, αυτός. Έλα, μην αγχώνεσαι, ή από εδώ ή από εκεί θα έχει. Εβί, πώς θα μιλάνε.
Έλα λίγο. Το φως ένα. Το φως ένα. Αυτό με το δείτε. Καλύτερα το δείτε.
First of all, a visual method to measure the speed of light is to place chocolate in a microwave oven until the chocolate starts to melt. And then we have to measure the distance between the hot spots that are created. We were challenged to investigate this effect and find the accuracy of the method. Now, an introduction to the problem. Okay. It is highly believed that it is possible to measure the speed of light with sufficient accuracy using a microwave oven and a material that melts, in our current example, a chocolate. This could be achieved by calculating the distance between melting spots of the chocolate in a microwave oven, although others challenge the accuracy of the method. Now, some theory about the problem. First of all, we use some variables to set some values. D is the distance between the melted spots. F is the microwave frequency, which is constant. It is 2.5 gigahertz, which is 2,450,000 hertz. And C is the speed of light, which is this number. And L is the wavelength, which is equal to 2 times the distance we found between the melted spots. And using the wave equation shown here, V is the wave speed, F is the frequency of the wave, and lambda, as seen here, is the wavelength of the wave. And using this equation, we solved it for C and found this equation, 2D multiplied by the frequency. Now, how to calculate the accuracy, which we're challenged to check? We set another variable, A, which is equal to the actual speed of light minus the speed of light that we found. The error percentage is the A variable multiplied by 100 and divided by C, the actual speed of light. And the accuracy we need is A minus is 100 minus the error that we find. Okay, now how does a microwave oven work? First things first, the food chamber, this area. Its main purpose is to keep the food clear from microwave radiation. The vacuum tube located in this area, in this side of the oven, is a gadget which is mainly responsible for creating electromagnetic waves and emitting them into the chamber, like this, shown in this image. Now, something about heat absorption that will be needed in our second hypothesis, which you will see later. Black surfaces like this one tend to absorb more colors, more light, and reflect none, although white surfaces tend to absorb less light because their white light is composed of all the lights, so it reflects them all. Now, our hypothesis. First of all, we made a hypothesis that the further the chocolate is from the center of the oven, it is hit with electromagnetic waves unevenly, so the accuracy of the method is lower. When the chocolate is a lighter color, it absorbs less light, so the hotspots are less visible, creating measurement problems and accuracy problems. The smaller the size of the chocolate, the fewer the hotspots, so it would be harder to measure and have accurate results. This is the equipment we used, an app called Measure, a microwave oven, and a ruler, and some toothpicks to pinpoint the points from which we measured. Now, our experimental procedure. We started by placing one chocolate in the center of the oven, and after one in the opposite side of the oven, and let it melt. We measured each distance to more than one time to be accurate, to be sure that we have accurate results. This is us checking the variables. First of all, the independent one is the location in the microwave. The dependent one is the proximity to the speed of light and the accuracy, and these are the constants. Now, our experimental results. We find that the chocolate in the non-vacuum tube side has an accuracy of 97.68%, and the accuracy in the chocolate that was in the center had a 98.6%, which was pretty close. Now, in our second experimental procedure, we tested the second hypothesis, which states that chocolate in whiter color tends to reflect all the light and have faded melting spots. Now, this is checking the second table of variables. The independent one is the color of the chocolate. The dependent is the proximity to the speed of light and the accuracy of the method. And the constants remain the same. Our results for the second experiment is the accuracy of 97.41%, which is how accurate the method is. And comparing it to the type of chocolate with a brown chocolate, which is 98.3, we consider below 3% to be a negligible difference. And then, okay, our third experimental procedure, we started off by having a chocolate that is smaller than 7 centimeters and putting it into the oven. This is us checking our variables for the third experiment. The independent one is the size of the chocolate, the dependent is the proximity to the speed of light, and the constants are almost the same. And our accuracy for the third experiment is 94.09%, which is above 3%, so we don't consider it to be too accurate. Okay. Now, for you to understand it more clearly, we show you some graphs. This is the ideal amount, and this is the speed we found. This is the graph shown in percentages. As you see, we have this one, the place of the oven, the type of the chocolate, and the size of the chocolate. And as you see here, our first and second hypotheses were rejected, while the third hypothesis was accepted. Now, some things that we could have done better. We could have used the thermal camera to measure the center of the hotspots, but we didn't have such an equipment. And we could have melted and smoothed the chocolate to be more accurate. These are some references. And thank you for your attention.
Thank you very much. Now let's proceed to clarifying questions of the opponent to the reporter.
Okay, so when did you conduct the experiment? Day or night?
I don't see how this affects the experiment. It was conducted
So
in a microwave oven.
Okay, can you define what speed of light is?
What
yes
the speed?
No, yes.
I can tell you how much the speed of light is.
Yes or no? Can you define it?
Yes, it is
okay.
measured.
Can you define the criteria of the sufficient accuracy as mentioned in the theory?
I'm sorry, could you rephrase that?
Can you define the criteria of the sufficient accuracy and as you mentioned in the theoretical explanation?
The variables are the
yes
ones.
or no?
Yes, the variables are the ones
okay.
that check the accuracy of the
thank
method.
you. Do you have any
pictures
about the experimental procedure?
I'm sorry?
Do you have any pictures about the experimental procedure? Can you show it in your slides?
How it is in the...
Only for that experiment.
How? I'm sorry, what?
Next question. Can you define what a wavelength is?
The wavelength is how much a crest from another crest is the distance.
Okay, do you write it in the presentation?
What the wavelength is?
Yes, it's very important.
I can explain it to you if you want.
Okay. So, what type of chocolate did you use?
I used the same type of chocolate every experiment except from the second experiment, which was a white one.
Yes, what were the types of chocolate?
It was brown chocolate.
Do you write it in the presentation?
It was the same type of chocolate. I think I wrote it.
Can you show me?
It was a full milk chocolate, and then it was a white chocolate. Let me find it.
In the parameters.
No, that's it.
Okay, until you find it, I have another question. Why did you keep the placement of the, how did you keep the placement of chocolate constant? Did you use any ruler?
We measured the distances of the microwave oven, and then we checked.
How?
With a ruler.
Do you write it in the parameters?
I say we keep the location in the microwave oven stable.
How?
So
do you have any criteria?
the measurement. We measured the distances, so we kept it the same.
Oh. Thank you.
Thank you very much. Opponent, you have 3 minutes to prepare your opposition.
Μα εγώ κάνω τώρα. Mavromati, and I'm the opponent from Team Big Bang for the first problem, chocolate and microwaves. So the overall point of the presentation was that the theoretical explanation and the presentation were good, but the hypothesis and experiment and theory and experiment need some work. So this is the problem we are investigating, as a reporter mentioned before. Hypothesis and experiment, the pros are there were enough variables used, good explanation of the experiments and results, and there were enough repetitions. Although there was no research question, only hypotheses. There were unclear hypotheses. There were no details on them in some of them. There were no pictures of experimental setup in all experiments. No error bars in some graphs to minimize the deviations, and graphs only used for the last experiment. So theory versus experiment. The pros are the connection between hypothesis and theory was mentioned, although hypothesis was relevant with theory. Although they didn't back up the results with the theory, there wasn't any evaluation, a connection with theory, and the possible errors were omitted. Suggestions for further improvement: use bullet points, more repetitions, add evaluation, be more specific when mentioning the constants, more pictures of procedure, possible errors, add error bars, and have more theory about wavelengths. Also, about the reporter's theory, the pros are that there was a good explanation of how the speed of light is calculated. There was loud and clear voice. There was a good explanation of the pictures. And although there was no explanation about how waves work and the standing waves that are produced by the microwave, there was no explanation of the way that the waves interact with the chocolate in order for the formation of the hot spots to be created. And there was no explanation of what wavelength is. Thank you very much for your time. These are the topics for discussion. And thank you very much for your time and attention. Το θεωρητικό ήταν, ρε παιδιά.
Please proceed to the discussion part.
Ας εντάξει. So, εντάξει ρε παιδιά, τι να κάνω. So, thank you for your presentation. It was very nice, although I have some questions to make. So, firstly, before you said that you can define the criteria of the sufficient accuracy, can you tell me which of these are the criteria?
What do you mean the criteria?
In the theory, you mentioned the sufficient criteria. Here, go back. The sufficient criteria of accuracy of the experiment. In the third slide. Here, can you tell me the criteria?
The criteria is a good checking of the variables. Nothing more, nothing less.
Did you mention that on the presentation?
This is included in the experimental process, good checking of the variables, and I think I did a pretty good job at
thank you. How did you find the center of the oven?
As I told you in the clarifying questions, I used a ruler to measure the distances of the oven.
Can you show me a picture or a text that says that?
Of the microwave. We don't have a picture.
Okay.
I don't think it is needed.
Okay, thank you. No, I have some questions more to make. So in the second hypothesis, you mentioned about types of chocolate.
Yes.
Can you tell me how and why didn't the different types of chocolate affect the results?
Now, as I said in the theory, I don't know if you understood that, but as I said in the theory, right here, darker surfaces tend to absorb more light and more energy, so the hotspots would be much larger, and the accuracy would mean...
Okay, well, don't you think that the cocoa solids are also a factor of the results? The solids of the chocolate, because white chocolate and brown chocolate have different solids, and the time spent on microwave is different. So how did you keep constant the time?
As I showed you in our 1 minute.
Yes, I know, 1 minute.
Yes.
Where did you find that 1 minute?
1 minute is the time it took to melt, not completely, so that we could have some melting points, but it is not a time where we couldn't have any melting points.
Where did you find that minute? Did you make any research about that?
We tested it, and we found that 1 minute is the exact time.
Well, what I mentioned before is that not only the color of the chocolate is a factor, but also the ingredients. Don't you agree with that?
What do you mean the ingredients?
The ingredients of the chocolate, because white chocolate and brown chocolate have different ingredients.
How would the ingredients play an important role?
Well, as I mentioned before, it's about the solids and how fast they melt. Okay, next question. What did you use to measure the size of the chocolate?
I'm sorry?
What did you use to measure the size of the chocolate?
A ruler. And the app, I said measure app.
Can you show me the app?
Yes. This is the app.
Okay,
right here.
Thank you. How much was the size of the chocolate?
The first one were here, this one is 15 centimeters.
Do you write it in the slides?
I say we keep the type of the chocolate same and the size of the chocolate as you see here in our variables.
Well, you don't write the size.
I write right here.
Next question.
Do you see? Size of the chocolate.
No, I say about the specific, the precise size of the chocolate. Next question. Do you have any theory that you based on the parameter about the equation of the accuracy of the method?
I'm sorry?
You mentioned in the theory about a new parameter that you created for the accuracy of the method. Do you have any theory that you based to create that?
We found in the internet that is a standard deviation formula.
Do you have it here?
Okay, thank you. Thank you.
Thank you.
Time is up. Thank you. Now stand up. Stand up. Let's proceed with clarifying questions by the reviewer to the reporter and the opponent.
First of all, for the reporter,
yes.
What kind of waves are in the microwave?
Electromagnetic waves.
Are they a specific kind of electromagnetic waves?
Electromagnetic waves are a type of waves.
Okay, they're standing waves?
Yes. I don't think it is needed to mention it here because that's not what we're checking.
What kind of possible errors would you have added, because you mentioned it on the possible suggestions?
Okay, so we wanted to add about the stability of the frequency of the microwave because although it is 245 frequency, sometimes it is not stable. Also, we would also add the trials. We should conduct more trials.
Okay, thank you.
Oh, okay.
To the reporter again, would you think that the thickness of the chocolate affects the results?
No, I don't think, because we're just checking on the surface of the chocolate and the distance between the melted spots. So
generally, I mean, do you think that the thickness of the chocolate does play?
We actually tested that in another experiment, and we saw that it does not affect the results of the experiment.
Okay, because it does. Do you think that not measuring from the center of the hotspots would affect the results?
We actually tried to measure from the center of the hotspots as...
I said, what if it would affect if you didn't do it?
If I don't do it from the center, the measurement would be wrong, and wrong measurement means wrong results.
Okay, and also...
Okay, time is up. Thank you very much. You have 2 minutes to present your review. The reviewer now has 2 minutes to present, to prepare the review.
So, hello everyone, my name is Anthi Margaki and I will be the reviewer for this position. So, we are familiar with the problem statement. So, firstly, the pros are for the reporter. He included necessary theory on the calculation of the speed of light and the A variable since they acknowledge the possible error and also measure the occurrence. They also evaluated errors, said what he could have done better, and used a thermal camera. He also used a ruler and an app to measure. Now for the cons, he used white chocolate, which is not considered as chocolate since it does not contain cacao molecules. Used only one microwave and did not label the axis. It did not smooth the surface, although it could have been easily done. And moreover, he said that the thickness of the chocolate would not affect the results. He did not have enough theory on antinodes, melting points, etc., and not smooth the surface, although this would have been easier to be done. So now for the opponent, the pros are that he pointed out the lack of pictures, was skeptical about them having the microwave voltage as a constant, and she pointed out the lack of trials. Now for the cons, she insisted too much on definitions, speed of light, wavelength, asked mainly theoretical questions in the clarifying questions that were relating to the experiments and were self-explanatory or they have been covered by the reporter. She said there were no error bars, although they have been calculated correctly, and she said there was not an evaluation if there was. So now, the reporter in the discussion, he said he did not have any picture slides where he shows the calculation process when the opponent asked about the calculation of the distance and pointed out the lack of the visual aid. And we agree with the reporter. The opponent asked about the calculation of time and if the research has done, and he said he only tested it. We agree with the reporter. Asked about the calculation of the distance, used two different methods. We agree with the reporter that two were enough. And now suggests for further improvement. To the reporter, he could have used the thermal camera to measure the distance between hotspots, and instead of measuring up to minimize error, and make the measurement as reliable as possible, and to make the chocolate that it would be smooth. That would have been done. It did not have to do with the lack of resources. The opponent dominate more on the discussion, insist more on the use of a ruler or measuring device, learn how error bars should be calculated, do not insist on divisions too much. So thank you all for your attention.
Thank you very much. Opponent, you have 1 minute for concluding remarks.
For your points of improvement, they'll take into consideration. So, firstly, I want to say about some things that I don't agree with the reviewer. So, there was no clear evaluation connection of results and theory, and there was no theory about standing waves, which is one of the most important ones in that problem. Not all graphs had error bars, and that's why we asked that in the questions. And I think I pressured enough the reporter in order to give me complete answers and understand and give him a chance to justify his problem. Thank you very much for your attention.
Thank you very much. Reporter, you have 1 minute for concluding remarks.
Okay, thank you both for your suggestions, although I have some final remarks. Some of the clarifying questions the opponent did were included in our presentation, and we believe most of our hypotheses were accurate enough, so our results were too. The graphs we showed were for all of our hypotheses and not just for the final one, and error bars were included. As long as the frequency of the microwave is the same in the microwaves, there is no error in the results. Also, I would like to both thank you for your suggestions. You did both an excellent job, and thank you all.
Thank you very much. I would please ask all three of you to stand up for clarifying questions by the jury. Where are your microphones? Microphones.
Το μικρόφωνο.
Anyone wants to ask a question?
I would like to ask the reporter, how did you put the sticks in the center of the melted piece of chocolate?
Could I have please my presentation? Right here.
Yes.
As you see, we try to pinpoint the center of the hotspots, creating an outline of them, and then measuring the distance between them.
How did you put this outline?
Using a Photoshop app.
Photoshop. Okay. Thank you.
Let me ask you something more for this picture.
Yes.
Besides the ruler, did you use any other kind of instrument, such as spacer or something else?
Yes, I said in the utilities I used an app called Measure to back up my measurements with a ruler.
Yes, I saw the app, but how exactly?
I'm sorry?
In what phase? I didn't see the usage of this application in your experiment.
We picked the points of the toothpicks, the distances, and the app calculated the distance between them.
Yeah, one question from me
Yes.
for the reporter.
Yes.
When you put the microwave oven on,
Yes.
The blade was rotating?
No, it was not rotating, because if it was rotating, then the hotspots wouldn't be created and we couldn't measure any distances.
I thought it wasn't mentioned, that's why I asked.
I think I mentioned it.
Okay, thank you.
A question for the opponent. How will you measure the distance between melted spots?
Between
The melted spots, the center of the melted spots.
Well, we would also use an app so that we would be more accurate. And of course, we would use a ruler not only to count the distance between the hotspots, but also the center of each hotspot.
Okay, thank you.
Yes, I'd like to ask a question to the reporter. Could you show us again the final graph of your results?
The graph?
Yeah, and if you could explain to me what am I looking at? The previous one.
Which one?
The previous one. Yeah.
Yes. You see in the y-axis is the speed of what we measure, the speed of light. This first bar is the speed of light that we found. The first bars are the speed of light that we found. The brown ones are with the brown chocolate. First of all, with the place in the oven, when we change the place in the oven, then when we use the white chocolate, and then when we change the size of the chocolate.
So the brown, let's just say the first part, the brown bar is about one place that you locate the chocolate bar and the speed of light that you calculated.
Yes, and the yellow bar is the actual speed of light and how much, and you see how much their difference is the percentage.
In your experimentation, you mentioned about that you placed it on two different spots.
Yes, one
you
in the center and one in the non-vacuum tube side.
Okay, thank you.
Okay, thank you very much. You now have 4 minutes for grading. Thank you. Please sit down. Are you ready? Jurors, are you ready? Ms. Mavidu? Okay, please show your marks for... Are you ready? Okay. Please show your marks for the reporter. Thank you. 20. Turn it to me. 20. Second, 20. Third, 20. 21. 22. 22. 22. 23. 23 and 24. Thank you. Now for the opponent. Wait. For the opponent, get ready. Are you ready? Please show your marks for the opponent. Let me see. 13, 14, 14, 14, 14, 14, 15, 14, 14, and 14. Thank you. And now for the reviewer. Please show your marks for the reviewer. Eight, 7, 8, and 8. Thank you. Thank you all very much for the first stage. You now have 5 minutes of break, and we will begin shortly with the second stage. Thank you very much. 5 minutes.
this title.
Δυνατά. Αν θέλεις, μπορείς να κατεβάσεις λίγο τη μάσκα σου. Μιλάτε δυνατά. Εντάξει. Έγινε. Θα σας πούνε τα παππούλια. Καθόλου. Δεν τον άκουσα καθόλου. Okay, we are ready now to begin the second stage of the final fight. Reporter, are you ready?
Yes, sir.
Good luck.
Is this open? Yes. Hello, everybody. I am Paris Ioannou, and I'm going to present to you our report for problem number 14, wave optics. So, the problem stated that we had to formulate an open, thought-provoking problem that concerns the phenomenon of wave optics. However, what exactly is wave optics? Wave optics refers to the branch of optics that studies interference, diffraction, polarization, and other phenomena for which the ray approximation of the geometric optics is not valid. This means that in this experiment, we take into account that light operates as an electromagnetic wave, which is according to the theory, of course, of the wave optics. Furthermore, we understand that the light travels in a straight line and that the light speed is constant, 300 million meters per second. And we understand also that it depends on the material for which the light travels for its speed. Now, the refractive index is really important because we are going to be using it a lot in our experiment. So, as you can see, each material is defined by a refractive index, which is called N. Every material has a refractive index since it's one of the fundamental properties of every material. As we can see in this here, the bigger the refractive index, the slower the light speed. So air, which has a refractive index of 1, is better for the speed for light to travel since it has a low a low refractive index. So, as we can see, N is the refractive index, C is the speed of light in a volume, which is the constant, as we know, 300 million meters per second. And we also have V, which is the speed of light inside the material, which we'll be taking into account in order for our calculations to happen. Now, there are factors that affect greatly the refractive index. One of them is the length of the wavelength. It's the wavelength of light. So, wavelength is inversely proportional to the refractive index. This means that the bigger the wavelength, the smaller the refractive index. So, because different wavelengths interfere to different extents with the atoms of the medium. The denser the medium, for example, the slower is the speed and the size of the wave. So, another very important factor is temperature. As we can see, refractive index is calculated at the standard temperature of 20 to 25 degrees Celsius. However, if we decrease the temperature below 20 degrees Celsius, the liquid will become more dense, resulting in a bigger refractive index, causing the light to travel slower in that index, causing the light to try to travel faster. As we can see, increased temperature is less dense liquid and can result to small refractive index. Now, Snell's law is really important. N1 is the refractive index of material number one, as you can see here. And this is the angle that creates the angle of incidence. Now, what happens is, when we turn the array or light, as we can see, this angle will be created, which is called θ2. This angle is the angle of refraction, which is calculated. And we know, as a fact, by Snell's law, that N1 multiplied by sin1 is equal to N1 equal to sin2. N1, of course, is the refractive index, and sin1 is the sine of the angle number named θ1. Now, dispersion is really important also. So, each material has one refractive index for each individual frequency of an electromagnetic wave. As we can see in this picture, and as it's explained here, this is why when rays of composite light, for example, when light passes through a prism, it's separated into those colors, which is always the colors that it separates to. The refractive index is higher for higher frequencies, as you can see. Now, here, for example, is the colors. As you can see, violet has a 400 nanometers as a wavelength, and red has a 665 nanometers as a wavelength. Our hypothesis. We guess, based on our theory and based on our research, we say that salty water index will be higher than the distilled water ones. We say that the highest the density of the salt water, the greater its refractive index. And we also say that the higher the laser beam frequency of salty water, the greater its refractive index. Now, for experiment number one, our dependent is, of course, the refractive index. And for the independent is the type of water. We use distilled and salted water. Now, of course, constants are the laser and color. We use green with 589 nanometers as the wavelength. Environmental conditions, room temperature is really important and it's kept in constant. Same tracker program, refractive index temperature, same thermometer, angle of incidence, amount of salt and amount of water are all kept constants. Furthermore, for experiment number two, our dependent parameter is again the refractive index. However, independent is the quality of salt in the water, grams per millimeters. We are essentially playing with the percentage of the solute in this case. So water type and amount, laser color, green, again the same. Salt type, environmental conditions, same room temperature, same index temperature, all of these, as you can see here, are all kept constants in order for our problem to be as accurate as possible. Now, moving on with the parameter number 3, dependent, again, the refractive index is what we will be investigating through this problem. Independent is the frequency of the laser beam, water quality, salt type, salt quantity, environmental conditions, same room temperature, angle of incidence, amount of water, same tracking program, and same laser beam are all kept constants for the accuracy of this experiment. So, for experimental setup, we use a distilled water in a glass bowl. We use one phone in order for pictures and recording of procedure to be happening. Salt, which is natrium chloride, laser beam, green and red, you will see later why, a ruler, a tracking program, and this website in order for us to calculate according to Snell's law. So for procedure number 1, we set and record the refraction of the laser beam. As you can see here, this is the angle. This is the angle of incidence, and this is the angle of refraction. We measure the angle of incidence and the angle of refraction. We use Snell's law with the help of this website to calculate everything. Same procedure for the salty water, of course, and we repeat the experiment 7 times in order for accuracy to be maintained. The procedure here is exactly the same. So we set and record, we measure the angle of incidence and the angle of refraction. We use Snell law. However, here we use different quantities of salt, and of course, all is salted water. And here we can see we set the record for refraction of laser beams in the salted water. We measure the angle of incidence and the angle of refraction. We use Snell's law to calculate. And same procedure, however, we use quantities of salt and both red and green laser. Here. So here are the results for experiment number 1. As we can see, there's no significant difference because it's 1.333 and 1.335, which is an insignificant difference as we found in our results, which of course is an average from all of our experiments. Moving on, we have here the difference. We see that here we have 30 grams of salt, and here we have 150. And as we can see, there is a tendency for the refractive index to rise, which is of course, because we add more salt. Moreover, here we can see that green is always has a larger frequency, and as we can see, it's guaranteed by all the different measurements we did for every time. So, here an experiment. The refractive index increases salty water. The refractive index is increasing because the solution is getting denser, and the higher the wavelength of light is, as you can see here, the higher the frequency. Moreover, conclusions by adding salt into the distilled water, the refractive index is decreased. We can calculate it with the help of Snell's law, and the refractive index is higher for light with higher frequency. References, and thank you very much.
Thank you very much for the presentation. Please now, let's proceed with live questions by the opponent to the report.
Like when you guys keep in order. Thank you.
Okay, so thank you for the presentation. It was very nice and interesting. Now, I want to ask you, I saw in the presentation that you said your environmental conditions were in control. I saw that you used the thermometer. What about the humidity? Did you test that?
Yes, we tested the humidity. The thermometer.
With what? I'm sorry?
Yes, we tested the humidity.
Okay.
I don't know, did you understand? Yeah, the thermometer had also the ability to measure the humidity. So humidity and temperature are important factors, and of course they were tested because we had to guarantee that our results will be as accurate as possible and as scientific as possible.
Okay, I saw that you said about temperature, how it would affect the refractive index. I'm not sure if you said anything about the humidity. Would it affect the results?
Yeah, no, because we actually believe like humidity and temperature. Here, one moment, please, for me to find. So here, yeah, no, temperature affects in a greater way than humidity this case. So we believe it's more important for us to explain how temperature is affecting the refractive index. As you can see here, there are all the categories and all the ways that temperature may affect.
So I saw also you used a tracker app. Was that to calculate the angle of the interface surface and the refraction?
Yes, you have to yeah, sorry, I will get used to that. So as you can see here, it is really important to be sure that this angle is calculated properly.
Okay, and what was the accuracy of this tracker? Do you know the accuracy of this tracker?
Yes, we of course chose a nav which is most accurate, because if it wasn't accurate...
Yes, I mean in percentage, do you have an accuracy?
I believe it's like, here you can see actually the app. If you can give me, it's this one here. Do you want to experiment with this?
Okay, it's okay. I also want you to tell me, do you remember the refractive index, the angles? What are the angles of these?
So I do not remember exactly the measurements. However, I can show you here the Snell's law, which is actually.
Okay, it's okay. So in one of your experiments, you actually had the independent frequency of the laser. Did you use different lasers, or was the one laser able to have different frequencies?
So here, actually, not different.
No, it's okay. I want to ask you something else.
I didn't answer.
Okay, I'm sorry. Okay.
Didn't you want me to answer? So,
sorry.
as you saw in our theory, colors, have different frequencies.
Yes. Okay.
And well, I cannot find it right now because you want to answer more questions. But frequency is different by colors because every wavelength has a significant frequency and it does not change.
Okay, it's okay. So now you had plenty of graphs and you had error bars. Why did you have errors in your bars? What was the possible error here, and what could have gone wrong?
The possible errors. Well, there's shocks. I believe. Well, actually, there are always possible errors. For example,
yes, but you calculated the refractive index. The refractive index, you said it was under controlled conditions, so why would it affect it?
Thank you very much. Time is up.
Thank you.
We thank both the opponent and the reporter.
No, keep that.
Opponent, you have 3 minutes to prepare your opposition. Opponent, are you ready?
Okay, so hello everyone once again. I'm Francesca Lacour and today I will be the opponent for this fight. So let's begin with my presentation and the general outline of the report. So beginning with the introduction, it was great because he explained what wave optics is, which we didn't really expect, but it was nice of him. Now the theoretical explanation was great. He the refractive index, how it's calculated. He included a few things about light and the fact that it travels in a medium in a ray. Now, the setup, I think, definitely needs some improvement. I understand he wanted to track the angle with an app so that it would be more accurate, but I really think that you should probably know the accuracy of this measurement and also be able to tell me what the angles were, because we weren't able to actually calculate them themselves and verify your results. Now for the experiment, I do believe that they were quite average. The data analysis needs improvement because you didn't actually show us all of the graphs, and I'm pretty sure that you included error bars without being able to explain to me why you did this, and you didn't really calculate them the correct way. And now for the deductions, they were good, they were clear, and very understandable. Now for the theoretical background, beginning you include theory of wave optics, as I already said, and you had sufficient explanation of the refractive index. It was very understandable, and I think everybody understood it. Now, you also had plenty of references. I think that is very important, especially when you're talking about theory, so it makes your theory more reliable. And you included visual aid, which made us, we appreciated it, especially when you showed the prism and you showed how the white light refracts when it goes through it and how the refractive indices affect this. Now, you did not actually change the problem statement that much. You said that you would, but you only explained to me what wave optics was, and therefore this is a requirement for the event yourself. You should have done that. Now, you didn't have enough theory on the link between wavelengths and wave optics. You talked about them separately. I think you should have probably done more on that. And also the hypothesis were not linked to the theory. You didn't actually specify to me how the salt water affects the refractive index. Now, for the experiment, you had plenty of constants. You had the environmental conditions controlled. I'm not really sure how you did it because you said a thermometer. I didn't know the accuracy of the measurement, but you still did, so I will trust you on that. Now, you include the graphs that help with our understanding of the phenomenon and the data presented, but as I said, most of them were not really presented. And finally, you tested the humidity, but did not really mention it and how it affects it. You weren't able to explain to me on the clarifying questions either. Now for the cons, only one phone was used, only one tracker app was used, and you didn't actually specify how the angle was calculated. You just said that it was verified by the Snell's law. I don't really think that's enough for me to understand how you did what you did. Now, you did not include instruments. You didn't explain the difference between using green and red laser. You talked about the effects on the results. You talked about the frequencies, but you didn't actually say how the frequency affects the results. You didn't have clear results, and you didn't actually confirm or reject your hypothesis. You just said your conclusions, and you did not include possible errors, although you had error bars, but once again, they were not calculated properly because you didn't explain to me how they were, so I believe you just did it randomly. So, I'm sorry. Okay, so some suggestions for further improvement. I would like you to include theory linked to your hypothesis. You tested salt water mainly, and you didn't have much theory on that. You should include the instruments you used in the experiment and mainly the accuracy of them. I didn't see any accuracy. I didn't see any possible errors on the accuracy. And also, you didn't include possible errors or an evaluation of your experiment and perhaps some things that you could have done better. Now, you didn't specify how salt affects the results. You also said that you... okay, I'm sorry. Thank you very much, everyone.
Thank you very much. Now, let's proceed to the discussion part.
The presentation.
Okay,
can you wait a minute? Sorry.
Okay.
Can you wait so that the presentation is linked
I
on?
understand the question. I think you can answer it without the presentation?
Well, yeah, but like, can I just say some things because like,
I really want to ask you a question first. So I mentioned in my presentation that you didn't tell me actually in the clarifying questions how you include, how you calculated the error bars. I would like you to do that because it might be unfair.
Yeah, that's exactly what I want to say. There are some things that
nice.
you said that I didn't mention, so I want to clarify those things. So for the possible errors, there's always the device error, even though it's really little because of the accuracy.
Okay,
there's always the
what is
deviation.
the accuracy then?
1 minute. So there's always deviation in measurements of constant parameters. Well, of course, even though they are maintained the same.
Okay, but what kind of deviations, what kind of accuracies? You're not being specific. You're just being vague. I know that the experiments have possible errors, but what kind of errors? What was the error here?
Well, the deviation is, of course, as you said, the accuracy of the app, but the accuracy of the app is rather high. However, there's am I doing that?
Okay, the accuracy of the app, do you think, what would be the deviation in the angles? Like 1 angle,
Can you say again?
Okay, he said that the deviations in the app, the possible errors could be here, could be there, I'm sorry. So what kind of difference would it make if you used a more accurate app? Would the angle be different?
Well, the angle won't be different because the angle is stable, and also we conducted the experiment 7 times. We took the average.
You used the tracker app only to test the angle, right?
What?
You use the tracker app?
Yes, you see, it's important to understand that, like, we measure this up and then you measure this up.
Okay, so where could the error be here? Where is the accuracy?
Yes, of course. So can you let me finish? Because I started saying that in the start,
I'm sorry.
and you didn't let me. So you can see here, we calculate, of course, this line here, which is the calculate of the incidence, and then you calculate this line here, which is the angle of refraction. We did this measurement, for example, for this parameter. We did that 7 times. We 7 times measured both angles. We 7 times made the refractive index. And then we conducted the average, eliminating the eliminating the accuracy problem, as you said, and therefore making our problems and our results.
Okay, so this proves that your results are reliable. So why did you include error bars in your graphs?
I know a scientist, I believe you know him too, is Stephen Hawking, and he said perfection in the universe simply does not exist. It would be stupid for me to say that I conducted an experiment and there's no possible error and there's no possible...
I understand, but I think you should be explained to talk to me about this error. You don't specify
I just mentioned those errors.
Yes, but you said you had 7 times tested anyways. So
yes, 7 times.
It's okay. So you had the camera. I think you took a photo, or was it a video? I mean, the picture here you have a demonstration.
Well, we have, of course, this is a photo because like the video couldn't load and we weren't so sure about how it would be able to play.
So was the camera parallel to the tank?
Yes, of course it was parallel.
How did you measure that? I mean, if it had an angle or not? Because I think the angles would definitely change.
Well, the angle does not change. You can see here is the light, here is the water, here is the one angle,
yes,
here is the other, and it's the photo. And of course, may I say, we did not use these pictures. Here is a representation. We actually, when we conducted the experiment, we actually used in order for everything. This is not how we did for everything. This is a picture for you to understand. Please, this is a picture for you to understand how the problem creates, and it's ordered for you as a visual aid, as you said.
I understand. What I'm saying to you, and you didn't answer that, is where was the fault? Because if I can see it from this picture, it should have been something like this. It's not parallel because we can see the water from below. So wasn't the angle? Isn't that a possible error?
What?
How did you keep the?
Do you want to see the video?
Okay.
Because like they were able to identify it. So you can see here. Do you want us?
You didn't use a tripod. I see the phone is obviously moving. So the angle, was the camera parallel to the water surface, or where was
Well, you can see here is the water surface.
Yes,
here,
I understand, but it's not parallel. It's clearly higher. So...
Well, we did not use this fault. We did not... I'm telling you. If we used the video was used in order for you to understand the experimental procedure.
But
it was not,
did you use a tripod?
You obviously do not understand because you keep making the same question. We used the video in order for you to see how the experimental procedure was conducted.
Okay, and I appreciate that. I really appreciate that. Okay, please let me finish.
Can I say why? Okay. We used this video in order for you to understand how this experiment is conducted.
Okay, and what I'm asking you, you're not responding to my question.
Well,
what I'm asking you is, how did you make sure that it was parallel? Did you use a tripod? Because in the video, I'm seeing that you used your hands.
Was parallel. The tracker was parallel. You are telling me about the video and the photos. We didn't.
Okay, thank you.
We have the clarifying questions.
I'm sorry.
This one? We have the second one. Because...
Αυτό. Μία εσύ, μία εσύ. Αυτό το παίρνει. Φορά. Αυτή δεν έχει.
Έχω αυτό.
Ναι, έχει αυτή, έχει αυτό. Θα κρατάς και πάλι.
Ωραία. Να πάρω. Όχι, αυτό. Φορά εσύ. Hello, I'm Agiliki from the reviewers team. Please, I have some questions for you. First of all, from the reporter. How many nanometers was the laser beam? Because I think you said that it affects or not. Can you please elaborate?
Say the answer again. Can you say the answer again? The question.
First of all, I would like to ask about the laser beams. Why did you use green and red? Why these colors?
Well, colors have different frequencies, and it's a great way for you to see, like, because they have the different color, you can understand that they have different frequencies. I explained it in my theory that, like, colors, every wavelength has a significant frequency. The frequency does not change under any circumstances. And I also explained about the wavelength, something that the opponent said I didn't. The wavelength also differs from colors. This is why we use colors.
Can you please go into your theory? In one slide, where you show all of the colors. So, as you explained to me now, was that the reason why you showed us this in your theory?
What theory? So here
the one where you show the colors? Here. So, you showed this to us, exactly this, why you chose green and red, to show the frequencies of the colors, correct?
Green and red, yes.
Yes. Also, what was the temperature in your room? Because you mentioned it was stable, but you didn't really say exactly how many.
Well, as I mentioned in my theory, it is important always when we are experimenting with the refractive index to have the standard temperature of 20 to 25 degrees Celsius.
I understand. Now for the opponent, I have a question. Why did you stand so much on the error bars? Because you gave too much base on the error bars.
Well, basically, the data analysis was based on the graphs. They were the only way they showed the results of their experiment. So what we care about here is the results and, of course, the experimental procedure. We saw error bars. They didn't exactly say what the error was. They said that, of course, every experiment has an error, and we know that. But
on that, what do you think the errors would be? Thank you.
Thank you very much. Reviewer, you have 2 minutes to prepare your review.
From the reviewers team, Team Lagrange, and I will be playing the reviewer for problem 14, wave optics.
First of all, let's look at some pros and cons for the reporter. He had a really well-structured presentation, and the theory was explained with photos and graphs. Also, he answers based on the theory, and his hypotheses were based on the theory as well. He had useful details, good definitions, and good eye contact and body language with the audience. Now, for some cons, he did not include error bars, nor data charts, and did not include photos of the experimental procedure enough for us to understand. He also did not include deviation, and parameters were not sufficiently clarified. For example, the angle measurement with the YAP. He should have used other parameters, and not only the concentration of the solution, and some slides were a bit too crammed. It was difficult for us to understand. Now for the opponent. The notices were logical. For example, the error bars, I totally agree. And the questions were relevant. She also had a very well-structured presentation and put pressure enough on the reporter. However, she asked about the tool for the angle of the measurement that was already mentioned, and she didn't say her opinion or made any improvements and suggestions. She also did not question the low number of trials, 7, we believe he should have used more, and did not let the reporter answer the questions enough. She was also a bit too repetitive and only stood on the error bars, and a bit bad time management and not so good body language. Now, as for the points discussed, the opponent asked how the error bars were calculated, and the reporter answered that there are always error bars and with no specific explanation. And the opponent asked why the error bars were there, and he answered all scientists include error bars. So what does it exactly mean? He didn't really elaborate. Last but not least, she asked if the camera was parallel to the water surface, and he answered it was using a tripod. Now, for our opinion on the debate, we agree with the reporter on the tripod providing enough camera stability, and we agree with the opponent on the one unspecified app being an insufficient tool. We also disagree with the reporter on error bars being included without reason, because you don't know why, and you didn't really calculate them. And we disagree on the opponent on the camera not being parallel to the surface. Now, some suggestions. I believe that the reporter should have tested more parameters. For example, passing through 2 solutions, and include error bars explanations. And now the opponent, I believe, that should have better time control to finish your presentation, and should have pressed the reporter on various points and not simply just one. Thank you very much for your attention. Good job from both of the teams. Thank you.
Thank you very much. Opponent, you have 1 minute for concluding remarks.
Okay, thank you to the reviewer for their insightful presentation and to the reporter for the fruitful debate. Now I want to say some things to conclude my presentation. Well, we saw that the main point of this presentation was to test different quantities of salts. But the only way we could actually see the results was either from the graphs being given or the observational analysis, the visual aid. No, the graphs were not presented, so I could not see the results, and I really pointed out the video, and I really wanted to make sure that they were parallel, because it was the only way for me to actually know the results. They did not talk about the angles, they did not talk about the sufficiency and the accuracy of their measurements, so how was I able to make sure if their presentation was reliable or not? Now, as the reviewer said, there was no standard deviation, and they said that it's, okay, so they should include error bars. I think that they should know why they should use them. Okay, thank you everyone once again for your time and attention.
Thank you very much. Reporter, you have 1 minute for concluding remarks.
I would like, first of all, to thank both the reporter and the opponent for their points, the reviewer and the opponent for their points. However, I would like to make some sections. First of all, I included error bars and pictures in my presentation, and actually when the opponent asked so during the discussion to explain why possible errors are possible, I explained why, and namely it was because the organs may have had some errors. Second of all, I didn't say all scientists use error bars. It is true, though. All scientists use error bars. But I said that Stephen Hawking once said that perfection in the universe simply does not exist. I didn't say that all scientists use error bars. Furthermore, I would like to say that you also mentioned in your presentation I should have controlled the light in the room. there's no, so you said it in when the reporter stood, and you said control the light in the room. To control the light in the room was simply irrelevant to this point because we were experimenting with refractive index of a laser beam. There were table graphs and photos of the experimental procedure, and I conduct the experiment 7 times for every parameter. Thank you very much.
Thank you very much. I would like to invite all 3 of you on the stage for clarifying questions by the jury.
Okay, I have first a question about the reporter. Okay. First of all, I have a question about the reporter. You said that you have repeat the experiment 7 times correctly?
Yes, 7 times for every parameter.
Why 7 times, not more?
We believe that 7 times were enough for every parameter, since the experiments were quite long and there were many things tested, and 7 times were enough for us to prove the tendency that we were required to prove.
Okay, thank you very much. And another question for the reviewer: how should the light in the room be controlled, by your opinion?
Yes, I believe it plays a really important role because it has to do with the visibility. Then you can see the angle of refraction clearly. So he should have mentioned how exactly was the light, and if there was an error bar included from the light in the room. That's why you mentioned it.
Okay, thank you. Thank you.
Okay, I have a question for the opponent. You mentioned if they use different laser or different phone. Why do you believe that?
Okay, so they used a tracker to actually make sure that the angle was the correct one. And what I wanted to say is, since they didn't mention the accuracy of this tracker, we would probably want to at least have more of them so that the deviation could be less. And I also talked, I said, what else did you ask me? Not
different kind of laser.
Okay, both I and the reviewer actually mentioned this. We saw a photo that had different wavelengths. They only tested 2. We think that it would be interesting to test different frequencies, different wavelengths, so that the experiment would be more full.
Okay, you meant different color of laser, not different kind of
well, both would be I think, preferable, because the colors would actually make the experiment more full with similar wavelengths. Okay.
A question to the reporter. You mentioned in your theory about temperature. And the importance of temperature on the liquid and the change in the refractive index. Did you change the temperature during your experimentation?
No, since if temperature is changed, then the refractive index will be greatly influenced and it will be changed. So we use the standard temperature, which is 20 to 25 degrees Celsius, so that...
So you did experiment with different temperatures?
No, we were based on our theory for this part of the problem.
Okay, thank you, thank you.
Okay, thank you very much. You now have 4 minutes for your grades. We are ready to announce the results. The grades, sorry. First, for the reporter. Jurors, please show your marks for the reporter. (22, 21, 21, 20, 20, 20, 21, 23, 22, 21. Thank you. Now, please, for the opponent. Please show your marks for the opponent. (16, 16, 16, 16, 17, 18, 18, 18, 16, and 16. Thank you. And finally, for the reviewer, please show your marks for the reviewer. Eight, 9, 9, 9, 9, 8, 6, 7, and 8. Thank you very much. We will have a short break of 3 minutes just to change the seats, and we will continue with the final stage of the final fight. Thank you.
Έχουνε μανταλάκι. Μισθό είναι τώρα. Μετά μόλις τελειώσει, θα το δώσουν ξανά επάνω. Αν ήρθε Απόστολος, θα του δώσουν ένα. Και τα δύο, παιδάκι μου. Όχι, αν ήρθε να μιλήσει. Ο Απόστολος να μιλήσει. Δεν έρθει να μιλήσει. Δεν τώρα την περιγραφή.
Εγώ να μιλάω εδώ. Δημήτρη, εγώ που θα μιλάω εδώ.
Καλησπέρα. Βρισκόμαστε σήμερα στην τρίτη ημέρα του διαγωνισμού και μόλις τελείωσε το δεύτερο stage και προχωράμε για το τρίτο.
Αυτός είναι ο μεγάλος τελικός του διαγωνισμού που φυσικά όλοι περιμένουν από τις προηγούμενες μέρες που διεξήχθη ο ημιτελικός και τα πρώτα stages. Όπως βλέπετε βρισκόμαστε στο αμφιθέατρο των εκπαιδευτηρίων Φρυγανιώτη που φιλοξενεί το διαγωνισμό για αυτή τη χρονιά. Απόστολε.
Νομίζω ότι έχουμε δει πολύ όμορφους αγώνες αυτό το διήμερο, όλα πήγαν καλά και με τη βοήθειά σας φυσικά και σας ευχαριστούμε πολύ. Ο διαγωνισμός τα τελευταία 3 χρόνια έχει δυναμώσει πάρα πολύ, 17 ομάδες φέτος. Μην ξεχνάμε ότι είμαστε και σε εποχή κορονοϊού και τα πράγματα είναι πάντα δύσκολα. Όλα τα παιδιά με εντυπωσίασαν με τις παρουσιάσεις τους, με τις δεξιότητές τους, με τον τρόπο παρουσίασης και εύχομαι να κερδίσει σήμερα ο καλύτερος.
Τέλεια.
Συγχαρητήρια σε όλους.
Τελειώνει το διάλειμμα και συνδέομαστε για τον μεγάλο τελικό που θα κρίνει και το αποτέλεσμα.
We are ready to begin the third stage of the final fight of the Hellenic Young Naturalist Tournament. Reporter, are you ready? Opponent, are you ready? Reviewer, are you ready? Good luck to you.
I'm going to be presenting my team's report on problem number 15. Let's jump straight away into the problem statement. So we were asked to study both theoretically and experimentally how artificial light affects human circadian rhythms and thus sleeping patterns. And now, what is circadian rhythms? The regulation of sleep is processed by the homeostatic physiology of the circadian rhythm, the sleep-wake cycle. The term circadian comes from the Latin phrase circa diem, which means around the day. Circadian rhythm is a 24-hour internal clock in our brain that regulates cycles of alertness and sleepiness by responding to light changes in our environment. Our physiology and behavior are shaped by the Earth's rotation around its axis. This biological circadian system has evolved to help humans adapt to changes in our environment and anticipate changes in radiation, temperature, and food availability. Now, how does the circadian rhythm work? So the circadian rhythms throughout the body are connected to a master clock, sometimes referred to as the circadian pacemaker, located in the brain. Specifically, it is found in the suprachiasmatic nucleus, which is the part of the brain called the hypothalamus. At different times of the day, clock genes in the SCN send signals to regulate activity throughout the body. Now, how does light affect our circadian rhythms? So basically, light majorly impacts circadian rhythms, and most people's internal body clock roughly follows the patterns of the sun. As a result, exposure to artificial light outside of daytime hours can disrupt our circadian rhythm, and in turn, our sleep drive, the time it takes for us to fall asleep, the amount of deep and REM sleep we get, and our general attentiveness. Here you can see a visual representation of our circadian rhythm clocks. Basically, at 9 p.m. is the point where the body starts secretion of melatonin so that we get to start feeling sleepy. At 2 a.m. it's the deepest stage of sleep, and at 7:30 a.m. the melatonin secretion stops, so we gradually start to wake up. So these are the factors that affect the circadian rhythms. So basically, exposure to light, temperature, caffeine consumption, age, gender, and diseases. In our experiments, we're going to be investigating the exposure to light, but we felt that it was important to include the rest of them because we keep them as constants. So the first hypothesis we made was that the use of blue light emitting devices 1 hour prior to sleep will increase the amount of time it takes for subjects to fall asleep, the light stage. So here are the variables of our experiments. The independent variable was the use of blue light emitting cell phone 1 hour prior to sleep, which was yes or no. The dependent one was the amount of time it takes for a subject to fall asleep, also known as the light asleep stage. And the constants were the electronic device that was used, the inches of the cell phone, the dark mode and night mode that was not used, the screen brightness, which was set at 100%, the age of the participants, which was 35, the room temperature, which was set at 20 degrees Celsius, the humidity, which was at 50%, the light conditions in the room, caffeine consumption, which was known, gender, which was males, health of the participants, which was no chronic diseases, and the same sleep tracker for everyone. So here you can see the instruments that we used throughout our experiments. We have a cell phone, we have a lamp, which was the only light source in the rooms. We also have an Arduino sensor to test the humidity, the temperature, and the conditions of the room. And we have the sleep trackers. So here you can see that the lamp was the only light source in the room we made the experiments in. And as for the procedure, we recorded the sleeping patterns of around 20 adults of 25 years of age with a sleeping tracker for 10 days during the holidays, so that we know what disrupt their waking up patterns. So here we can see that in the first 5 days, from Monday to Friday, we gave 10 of the participants a blue light emitting device, a phone, to use 1 hour prior to sleeping. The group B, the other 10 participants, were given a book. Next slide. Okay, yeah, the next 5 days, from Saturday through Wednesday, they did the exact opposite. So we basically switched the groups. Group A now has the phone, and Group B now has the book. The sleep tracker tracks the exact time that we fall asleep and wake up. In order to calculate how much time it took the participants to fall asleep after leaving their book or cell phone, we asked them to note down the time they left it and switch off the lights. The time it took them to fall asleep was given by T equals T1 minus T2, where T1 stands for time they fell asleep, and T2 time they noted down. So here we can see the results. Group A took around 11 minutes to fall asleep, and we can see it in the graphs. And Group B, which was the group that had the phone prior to sleeping, took 21 minutes to fall asleep after leaving their phone down. In the second week, we can see that Group A actually needed 24 minutes to fall asleep after leaving their cell phones to the nightstand, and Group B, that was switched to the book, needed 12 minutes to fall asleep. Now, the second hypothesis that we made. The use of blue light emitting electronic devices 1 hour prior to sleep will shorten the sleep duration. So the control of variables, the independent was again the use of a blue light emitting device. The dependent was the sleep duration this time. And the constants were almost the same. So the sleep tracker, as we previously mentioned, tracks the exact time we fall asleep and wake up. The sleep duration was given by this formula, where T1 stands for time they woke up and T2 time they fell asleep. Therefore, this process did not require any human intervention. Here we see the results. We can see that Group A, when they had the book, slept much more, had a longer duration of sleep, and Group B with the phone had least duration of sleep. And the third hypothesis that we made was that the use of blue light emitting electronic device 1 hour prior to sleep will decrease the percentage of deep sleep and REM sleep, and it will increase the percentage of light sleep in a single sleeping session. Here we can see the independent variables, which was again the use of the device. The dependent, which this time are the percentage of deep sleep, the percentage of REM sleep, and the percentage of light sleep. And the constants were the same. So the sleep tracker tracks the type of sleep one gets and the percentage of each time, REM, light, deep. Therefore, this process also did not require any human intervention. We simply recorded and averaged the results. Here we can see the results, and we can actually see that the group that had the book before falling asleep had much better quality of sleep, since the duration of their deep states is bigger than the ones from the participants in the group that used the phone. Possible errors that could have occurred in our experiments were the accuracy of the sleep tracker, which was at 78%, the eating habits of the participants that were not taken into account, the participants' exposure to light during the daytime, which we could not control, and the distance between the eyes and the screen that we could not measure because each person holds a phone at a different distance. So all of our hypotheses were actually confirmed, and this is our bibliography. Thank you very much for your time and attention.
Thank you very much. Now let's proceed with clarifying questions from the opponent to the reporter.
Okay, so you had a really good presentation. I would just like to ask you a few things. First of all, how did you determine the accuracy of the sleeping tracker, which you mentioned was 78%?
It is mentioned in the app description. It is given by trials, and they found out that the error was around 22%, so they have it as the accuracy of the app.
Okay, go to your variables.
Could you repeat?
Could you go to your variables? I need to see
The
something.
variables, yes, sir. In which experiment? They were different for
In the
each
first
experiment.
one.
In the first experiment. Please go to the first experiment. The dependent, the independent, which ones would you like to see?
The constants, please.
The constants, yes, sure.
Yes, did the diet of the participants play any role?
We mentioned in the possible errors that since we did not take into consideration the diet, it could have been a possible error.
Okay, and also, did the participants use the same cell phone?
The same cell phone?
Or just cell phone?
We specified that the screen had the same size, so and the brightness was set at the same level, so it did not play
Yes,
such a
okay, but
significant
do you
role.
realize that different phones, 100% brightness is different for each phone?
I don't believe that that's correct because most of today's phones have the same settings.
Yes, well, that is not true. Anyway, why did you choose to conduct the experiment on only males?
Only males. We wanted to test only how light affected the sleep, and we thought that using women as well could have changed the parameters, and that's the results.
Yes, I understand that, but why only males and not only females? Is that for a specific reason?
We just chose males because their sleep circadian rhythm is much more stable.
Okay, and lastly, do you think the temperature of the room plays any role in the sleeping patterns?
Yes, it could play a role, but I believe that we specified it was set at a certain point. That's why we used an Arduino sensor to keep the temperature stable.
Okay, and for the lamp you used, was it the same lamp throughout the
Yeah, it was
experiment?
the same lamp for each participant to each room.
So,
Same
were
contact,
they
same
your
brightness.
rooms, or did they go? Do you give them the lamps to take home?
Excuse
How
me?
does that work?
The rooms were controlled. We had them stay in a hotel. They did not conduct the experiment in their house because they could have had different light sources.
Okay, and also you mentioned they were healthy, they had no diseases. How did you figure that out?
We asked them for doctor prescriptions and we saw their historical background to see if they actually have any diseases.
Any diseases at all, or ones affecting sleep?
Any diseases at all, because we could not test how each disease affects sleep. For example, if you have diabetes, it could have been that it's harder for you to fall asleep.
Okay, and lastly, what were they doing on the phone? You mentioned they were using the phone beforehand. What were they doing with the phone before sleeping?
Excuse me, I couldn't hear you.
How did they use the phone before sleeping? Did they do anything they wanted, or?
We did not give them specific instructions. We just told them to use their cell phone however they wish.
Yes, but in different apps, the color is different, so the brightness is different. So couldn't that affect the results?
In all apps, the emission of blue light is the same, so it affected the sleep patterns the same way. Thank you.
Thank you very much. Opponent, you have 3 minutes to prepare your opposition.
Okay, so hello again. I'm Pavramidis from the team Lagrange, and today I'm going to be the opponent of the team presenting biological clock. Now, first of all, the theory, the strengths and the weaknesses. We believed it was a well-structured presentation, including an introduction. It presented the problem really well. Hypotheses were connected to the theory and really interesting. And the definition of the phenomenon was also good. Now, they didn't include enough visual data in pictures in theory. They included some irrelevant pictures about Earth and something else. We needed something to look at so it can be explained better, the phenomenon. Now, they mentioned error bars and there were inaccuracies in, for example, the sleeping tracker, but they didn't mention how the error bars were calculated. Why were they at that amount? There was too much text in the slides, and in one picture they even mentioned melatonin without having explained that at all, what it is and what it does. But it does play an important role in the process. Also, body language was pretty average and there was bad time management. Moving on to the experiments. The procedure was really good and they were well conducted. The variables were kept controlled really well. However, the environment, we believe, was not sufficiently controlled. The cell phone, as I stated earlier, was not controlled. It was not the same, so the brightness could have been different, and that obviously can have affected the results. Then, data charts, error bars, all that, we believe was not sufficient enough. As I'll say later, the charts could have been better, and the error bars I already mentioned, they didn't explain how they got that number. Now, the experimental procedure had no photos whatsoever. We don't know what happened, how the room was, where they slept, the lamp, nothing. We don't know any of that. And finally, the charts were barely explained. Now, for missing points. Could the first 5 days affect the next 5? They mentioned that the first 5 days, they didn't use their cell phones, and the next 5 days they did, but could, for example, the withdrawal of a cell phone could have affected how the person felt, how they slept, psychological problems, for example. Next, the environment was not controlled correctly, as I said earlier, the external light, the lamp, what they were doing with the phone, that was not correctly measured, and also the diet, as I stated earlier. And as I again stated earlier, what is melatonin? It wasn't mentioned at all. It is a really important role, and we believe it should have been noticed for the experiment to be well conducted. Now, we believe there weren't enough graphs included. For example, there could be one comparing all categories. How did the withdrawal of phones have affected? In the other, how did they sleep in comparison to each other through different parameters? We believe that would have been a really interesting comparison. Now, for the suggestions. First of all, use more variables. Coffee and diet. Coffee, we do believe the caffeine was really good, but diet is extremely important to how a person sleeps, and this is why it should have been included. Also, specificity is really important. How was the tracker accuracy measured? It said it in the description, but I don't know, you don't know how it's measured. You should have measured it yourselves for a valid experiment. Couldn't have controlled the environment better. We still have questions about the lamp, the phone, all that. And also, it will really help if we were more vivid when you were presented, so we could understand what you did better. Thank you. Can we start? Excuse me.
So thank you for the points made. Okay, so thank you for the presentation. I would actually like to specify once again that the lamp was the same for each room, and the conditions were controlled since we had an Arduino sensor for both the temperature, the light of the room, as well as the humidity. So the room was the exact same for each participant, and the phone had the exact brightness, no dark mode, and the screen was the same inches.
Yes, what we questioned isn't that the lamp isn't the same in each room. It was what that lamp is. Was it really bright? Not that bright, was dim? We don't know that. You didn't mention that at all.
The lamp was at a voltage that would not affect how humans sleep, and it would not affect the circadian rhythm.
So you think the brightness of the lamp does not affect how a person sleeps?
So basically, our whole experiment was based on blue light emissions. The lamp was not blue light. Blue light comes from phone devices such as phones, computers, etc.
Yes, but in order to have good to conduct a good experiment, to have a good resolution, don't you think you should have controlled the other parameters so you know that your results are based on just the blue light?
Yeah, we did have them controlled. The lamp was 10 luxes, the lamp was the same for each room, it was not blue light, so it did not affect the circadian rhythm, and we had all the parameters controlled. I'm not sure what you mean here.
Yes, what I mean was the lamp could have been too bright to have normal results, but anyway, let's move on to something else. Okay. Diet. How exactly did you control diet? Are you aware that, for example, a person in a caloric surplus has more energy and therefore it's harder to sleep?
Yeah, I'm sure what you're saying is correct, but we said in the possible errors that we did not consider diet, and our experiment was based on blue light emissions. If we wanted to test how diet affects sleep, it would have been an entire whole other experiment.
Yes, but not having that as a constant is extremely wrong, because having that not as a constant, your results could just not be valid. Everybody could eat whatever they want.
That's why we added it as a possible error, and that's why we have error bars. You can see that we have caffeine consumption as a constant. All of those were the constants.
Okay, but for something as important as diet, error bar should have been gigantic.
The objective of the experiment was not to see the diet, was to see the blue light emission and how that affects the circadian
So
rhythm.
the other should have been kept a constant. I said that earlier.
Okay.
Anyway, you mentioned that the size of the phone was the same. How do you think that would have affected the results?
Well, if the screen was bigger, the blue light emission would be much greater, so the circadian rhythm would have been much more affected.
Okay, and also for the use of the phone, what were they doing before? For example, don't you think somebody watching a horror movie could have slept worse than somebody who didn't?
It would not be logical to tell them what to do with their phones. Since it's an experiment, it is not like we can tell them, go on that app, do that for that exact time.
I think it's exactly what you should have done. You should have kept that constant so your results are good.
Okay, I disagree, but okay.
Okay, and did you use one tracker app or many?
One tracker app?
Did you use one tracker app or many?
So basically, as you see in the experiments, in the instruments used, they had the clock, and it's sufficient enough to see the results. If you use two trackers, they would have the same exact result. Since it's on the same participant, on the same hand, on the same
But you did mention that in the one you did use, it was 78% accurate. Couldn't you use one that was also as accurate so you can compare the results?
If we use two, that does not mean that the accuracy would be greater. Both of the apps would still have an accuracy percentage of 78%.
Yes, but if the result was the same in both of them, you'd be more sure that that result is correct, right?
So what did you have me do? Place 3 clocks on each hand?
No, it could have been the same clock, but just two different apps installed, and you can see the results on both of them. It's really simple. It could have improved the experiment a lot.
Two different apps. Don't you think that the variables would be too big to count then? And the differentiation between the results could have not led to sufficient results?
No, not at all. I actually think you'll be more sure of your results that way.
Okay.
Okay, and also, did you calculate the average of the results you mentioned, for example, the time?
Yes, you can see the graph that here we have the average of, we had 20 male participants, and here the number you see is the average. So we basically added them up and then divided them by the participants.
Okay, and just to clarify.
I would also like to say that we did not use graphs in all of our experiments, since sometimes not using graphs is better for...
Yes, I understand, but I do think it's really good to have visual data because it's not for you to present our problem, it's for us to understand them. And
we did have
yes,
visual data. You can see in the first experiments where visual data is needed as is in the graphs, we have used graphs, but in the other experiments it's much easier to...
I see one graph.
That's what I'm explaining. That's what I'm explaining to you.
Yes, but you just said graphs. That's plural, that's why.
Okay, yeah, sure. In the other two experiments, the comparison would be much easier if we just showed the results as templates, as we did.
Okay, and I'm really curious about the book you gave them. What happened if they wouldn't read the book? What did you do? Why did you give the book to them? Why did you decide that?
Excuse me, I couldn't hear you.
You mentioned you gave them a book in one of your experiments. What happened if they didn't read the book, and why did you choose to give them a book?
We did not oblige them to read the book. We just told them to not use any electronic devices. The book was just a way for them to pass the time.
So that's also uncontrolled if they read the book or not.
Please answer the question, last question.
No, it was not uncontrolled, since it does not play that big of a role. The whole objective of the experiment was to examine the blue light emissions, not to whether the subjects read the book or not.
Thank you.
Thank you very much. Please wait here. Please wait. Now let's proceed with clarifying questions by the reviewer to the opponent and the reporter.
The microphone. Okay. Oh, okay.
Okay. First, the first question is for the reporter.
Yes, sir.
how does the amount of activities can affect sleep?
So what I'm saying again and again here is that we tested the blue light emission, not whether the subjects were tired throughout the day, nor their diet. That would have been an entirely different experiment.
Okay. Again for the reporter, what was the use of the book in your experiment?
The use of the book?
Yes.
So we strongly encouraged participants to read the book so that they had something to do and so that the constant was much greater, but we could not oblige them to read the book, as you can logically understand.
And last one, for the opponent basically. Why should melatonin be mentioned?
Okay, thank you. Well, having read through theory, we know that melatonin plays a huge part in the circadian rhythms and the sleep-wake cycle, so it is something to be considered and at least mentioned in the theory.
Thank you. And also, to the opponent again, why coffee and diet should have been added as variables in the reporter's experiment, in your opinion?
Oh, sorry, you asked why is caffeine and diet important?
Why coffee and diet should have been added as variables in their experiment?
Okay, as I said before, food gives us energy. If we have a lot of energy, we cannot sleep. And also, caffeine also gives us a lot of energy. If someone has a lot of energy and cannot sleep, that affects the results. And therefore, blue light isn't the only dependent variable.
Thank you very much. And the last one, do you think that the size of the phone that you mentioned before can affect the research?
No, we do not believe the size of the phone plays a difference. We believe the brightness plays a difference and the blue light emission.
Okay, thank you very much.
Thank you. Reviewer, you now have 2 minutes to prepare your review.
Hi everyone, my name is Giannas. I'm from the team Big Bang, and today I'm going to present you our review report for the problem 15 biological clock. As an overall, the reporter and the opponent were both good. This is the problem to be investigated that we all know. And moving to the reporter, she had a loud and clear voice, nice design of the presentation, good definitions, a lot of constant parameters were put in the experiment, and that means accuracy of the experiment. There was a detailed experimental procedure, good explanation of the parameters they used, possible errors were included, and there was a good time management as well. However, it was not an easy-to-follow structure of the presentation. Concerning hypothesis, experiment, again back to hypothesis, no explanation of pictures, failed to answer successfully some of the opponent's questions, no explanation of how other parameters affect, such as temperature or caffeine, didn't mention how people use their phones, didn't mention the book type, if it was the same for everyone, considering the amount of text, size of letters, type of content. To the opponent, there were enough clarifying questions asked. To the point questions, spotted some errors of the experiment, explained in detail the missing points, enough pressure to the reporter, and let her answer completely, express his opinion on all matters. However, asked question already answered the presentation. The opponent contradicted himself during the presentation, mentioned that he both had and did not have introduction, insisted a lot about the lamp, and didn't mention the absence of introduction. The opponent believes that the brightness of the lamp does not affect the sleep-wake cycle. The reporter believed that the environment was well controlled. Then we agree with the opponent. The intensity of the light does not play a role in the experiment. Then the opponent insisted on the light being a constant. However, the report said that it's included it in possible error and was irrelevant with the hypothesis. We agree with the opponent. The specific amount of food can be different to each person. And the third one, the opponent said graphs are making the presentation more accurate. The report said that in this case, it didn't need graphs. However, we agree with the opponent. Not all experiments had graphs, and it would be more easy to observe. Here are suggestions for further improvement to the report and the opponent. And thank you very much for your attention.
Thank you very much. Opponent, you have 1 minute for concluding remarks.
Okay, for our final remarks, we would like to make some points and answer some points mentioned by the reviewer. First of all, for the experiment, they mentioned a lot of errors, and we do agree there were mentioned in the errors, but these shouldn't have been errors. If you know something is wrong with your experiment, fix it. Keep it as a constant so you know you are sure of your results. For example, they mentioned they controlled caffeine. They didn't mention how they controlled caffeine. Did you just observe them eating all the time? And if so, wouldn't that make it easier for you to just control their diet? And for the reviewer, they mentioned we were contradictory, that we mentioned there was the lack of introduction twice, yet he himself was contradictory, since he said we do not have it, and then that we repeated it twice. So did we not have it, or did we have it twice? Which one is it? So the closing, diet, coffee, type of phone, what they were watching on the phone. We believe the lamp was really important, brightness important, and good presentations by all. Thank you.
Thank you very much. Reporter, you have 1 minute for concluding remarks.
Well, thank you for the presentations, both the opponent and the reviewer. I would like to say that we specified that the no caffeine consumption was a constant in our experiment, and I would also like to say that the request for us to use more parameters in our experiment would have resulted in an entirely different experiment, when our main objective was to test how blue light emissions affect the circadian rhythm. Also, we did include the melatonin in the diagram that I showed about when suppression begins, and the environment was as controlled as possible. You cannot control everything in an experiment, and we did the best that we could. Also, we calculated the error bars through through the standard deviation of the human intervention and also the accuracy of the app. And I did say the number of participants to the reviewer who pointed out that I did not say the number. It was 20 males that were tested. And also I would like to conclude by saying that I stand by our experiment and I stand by the results that were given. Thank you very much for your time.
Thank you very much. I would like to invite all three of you on the stage for clarifying questions by the jurors.
Thank you. Okay. First of all, I have a question for the reporter. I know that you have answered already questions about the size of the cell phone and the brightness. Do you think that you should consider, or maybe you did consider it, the cell activity each person had before going to sleep? I mean, it's not the same just watching a video on YouTube or playing a video game or just reading or texting. Do you think that it's something that you should consider in your research?
I agree with you, but I do not believe that it is feasible for us to say to the subjects what exactly to do with their phone for an hour. We could not have said to all of them, just text for an hour straight.
Okay.
So we just let them do it by their own time.
Okay, I understand. Now, something about the sleep tracker. Did you consider an error factor about the time that each person falls asleep?
Yeah, that's what I meant by the human intervention, because the time that each person noted down as I left my book at that time, for example, could have been a variation in the diagram, so that was what we saw through the error bars.
Okay, and one final question for you. Could you explain to me the difference in the hormonal path that takes place in our brain, in the hypothalamus, when I fall asleep with blue light or not? Is it something different in what hormones are produced? Maybe their quantity? What exactly is going on there?
Okay, so basically we did not examine what hormones are induced by the use of blue light, but we rather saw the results of the blue light, and not why exactly it happens, but the results are what we cared about in our experiments.
Okay, now some questions for the opponent. What visual data would you use?
Excuse me?
You said about using visual data. What visual data would you use in your presentation?
Thank you for the question. First of all, we believe an image of how the layout of the room was, where they slept, how close the lamp was, that would have been really important to know the condition of the experiment.
Okay, and you mentioned the brightness and size of cell phone, and in your presentation did not say something about the cell activity, but I think that you said something about watching a horror movie later in the discussion. Why didn't you use that in your presentation? Don't you think it was not so...
Yes, well, the reason we didn't include that in our presentation was obviously because of time issues and because it was something we wanted to expand on during the discussion, just to be clear that what we were saying was correct.
Okay, thank you.
Thank you. Anyone else?
Okay, question for the reporter. You mentioned that the success rate of the app you used was 78%. So do you consider 22% of failure an acceptable rate?
Yes, we do, because all sleep trackers had around the exact same accuracy. So by using that, we sold it in the error bars. That was the error bars for the human intervention, as well as the accuracy of the app.
Okay. And for the opponent, you mentioned at some point in your presentation about the lack of graphs from the reporter's side. Do you consider that this is an accurate statement?
Yes, the only graph included was on the first experiment, and we also suggested a graph they could have used. We wanted to know how quickly the people that didn't use their phone fell asleep to the ones reading a book. That would have been really interesting.
Okay, thank you.
Any more questions? Okay, thank you very much. Please sit. Now have 4 minutes for your marks. Jurors, please show your marks for the reporter. "24, 22, 23, 23, 23, 22, 23, 24, 22, 19. Thank you. Now for the opponent. Please show your marks for the opponent. "15, 16, 16, 17, 18, 18, 18, 18, 16, and 16. Thank you. And now for the reviewer. Please show your marks for the reviewer. "7, 8, 8, 8, 7, 7, 7, 6, 7, and 7. Thank you very much. That was it. I hope you all enjoyed the fight and may the best of you win. Λοιπόν, στο σημείο αυτό έχει λήξει ο τελικός αγώνας. Θα κάνουμε ένα σύντομο διάλειμμα ίσα-ίσα για να προλάβουμε να ετοιμαστούμε και αμέσως μετά θα ξεκινήσει η τελετή βράβευσης όλων των ομάδων. Να είστε καλά.
Αν περισσέψουν τα μετάλλια να ζητήσουμε για μας. Εν τω μεταξύ, στο κάνει airdrop και μετά έχει iPhone. Δηλαδή, από ποιο άλλο μπορεί να είναι, ξέρω εγώ. Μήπως έχεις φωτιστεί για το η μαμά μου είχε ένα MLS. Το είχε πάρει από μπάσκετ και δεν φτάσει στο πόδι. Και μετά το πήρα χώρασε.
Μην ανησυχεί εγώ να το σου πω.
ασύρματο πάρε και το ασύρματο.
Όλα είναι έτοιμα για να ξεκινήσουμε την τελετή βράβευσης. Ήταν ένα φανταστικό τριήμερο. Για μένα είστε όλοι νικητές. Σκεφτείτε μόνο τι κάνατε μέσα στη χρονιά, πόσο κουραστήκατε και εσείς και οι καθηγητές σας για να μπορέσετε να καταφέρετε να είστε εδώ πέρα σήμερα. Γι' αυτό λοιπόν σας ευχαριστώ πολύ όλους και ένα χειροκρότημα για εσάς. Παρ' όλα αυτά όμως, σε έναν αγώνα πρέπει πάντα να υπάρχει και ένας νικητής. Και είναι καλό να υπάρχει νικητής, για να υπάρχει και ο λεγόμενος ανταγωνισμός με την καλή έννοια. Γι' αυτό λοιπόν θα ξεκινήσουμε τη βράβευση τιμώντας όλες τις ομάδες οι οποίες αγωνίστηκαν, ξεκινώντας με την κατάταξή τους κατά αύξουσα σειρά, δηλαδή από τον 17ο και θα οδηγηθούμε στον πρώτο. Για το σκοπό αυτό λοιπόν θα ήθελα να παρακαλέσω τον κύριο Τσιόγκα να έρθει πάνω στη σκηνή και να μας βοηθήσει στη βράβευση. Κύριε Τσιόγκα, δύο λόγια πρώτα.
Το χειροκρότημα ανήκει σε εσάς, όχι σε εμάς. Εμείς αυτό... Αυτό είμαι πρωτόφωνος.
Όχι, πρέπει να ακούσει την κάμερα.
Λοιπόν, το χειροκρότημα λοιπόν ανήκει σε εσάς, όχι σε μένα εδώ, σε εσάς όλους εδώ κάτω. Τους διαγωνιζόμενους, τα παιδιά, τους συναδέλφους εδώ, τους κριτές και όλους αυτούς που έχουν συντελέσει στο να επιτευχθεί αυτό το πράγμα εδώ. Όλο αυτό το όμορφο πράγμα, όλο αυτό το όμορφο ταξίδι θα έλεγα στη γνώση. Αυτό θα έλεγα να το αξιοποιήσετε. Να βγείτε σήμερα πιο σοφοί, πιο δυνατοί, πιο δημιουργικοί. Αυτά.
Ευχαριστούμε. Ευχαριστούμε πολύ και για τη φιλοξενία και για όλα.
Να είστε καλά.
Λοιπόν, κλείστε τα αυτά, κλείστε τα από κάτω. Στο κάτω. Ωραία, θα σας δίνουν τα παιδιά. Λοιπόν, ξεκινάμε από τη 17η θέση. Θα παρακαλέσω τις ομάδες οι οποίες γνωρίζουν τη θέση τους τουλάχιστον μέχρι τη θέση 4. Από εκεί θα ανεβαίνετε και όταν ανέβει η προηγούμενη ομάδα να είστε λίγο έτοιμοι και σύντομοι να ανεβείτε. Μην ξεκινάτε εκείνη την ώρα, να είστε ήδη εδώ πάνω. Εντάξει, σας ευχαριστώ πολύ. Λοιπόν, ξεκινάμε. Στη 17η θέση, από τα εκπαιδευτήρια Ράπτου, Απόλλω 22. Δώστε στον κύριο Τσιόγκα να τα μοιράσει, θα τους τα κρεμάσετε. Τα certificates και τα certificates. Τα certificates, έλα να τα δίνεις. Ο Γιάννης. Γιάννη, ραπ του R. Όχι, στα παιδιά. Καλά, θα τα πάρουν μετά, άστα. Ξέρεις τι, μην τρελαίνεσαι, ας τα πάρουν μετά. Άστα, θα τα πάρουν μετά. Παιδιά, κάντε λίγο πιο πίσω να χωράτε όλοι στην κάμερα. Γιάννη, άστο, είναι πολύ πέδεμα. Μετά θα τα μοιράσω. Εκεί μπείτε όλοι στη σειρά. Μπείτε όλοι στη σειρά να φαίνεστε όλοι καλά. Συγχαρητήρια. Στη 16η θέση, από τα εκπαιδευτήρια Παλάδιο, Works. Συγχαρητήρια και ευχαριστούμε πολύ για την πρώτη σας συμμετοχή στο διαγωνισμό και ελπίζουμε να σας ξαναδούμε κοντά και του χρόνου. Μη φύγετε, θα πάρετε και τα certificates μετά. Απλά για να μην φύγετε, θα πάρετε και τα certificates και μετά θα φύγετε. Ο Χάρης κάνει την εξής βαγιά, χώρισε του Ανατόλια. Ευχαριστούμε και συγχαρητήρια και ελπίζουμε να σας έχουμε και πάλι του χρόνου. Στη 15η θέση, Από το Κολέγιο Ανατόλια, η ομάδα Black Hole. Συγχαρητήρια. Μπράβο σας. Στη 14η θέση, από τα εκπαιδευτήρια ράπτου, 2022, The Scientist. Συγχαρητήρια στα κορίτσια που τόλμησαν να κατέβουν με μία ομάδα 3 μόνο ατόμων. Μπράβο σας. Στην 13η θέση, από το Κολέγιο Ανατόλια, Geology Rocks. Τα παιδιά δεν μπόρεσαν να είναι εδώ μαζί μας σήμερα. Ευχαριστούμε πολύ. Συγχαρητήρια, παιδιά. Στη 12η θέση, από το Ελληνικό Κολέγιο, η ομάδα Crew X. Επίσης θα παραλάβει τα βραβεία της αργότερα. Στην 11η θέση, από το Κολέγιο Ανατόλια, η ομάδα Everything is Relative. Πίσω από τη γραμμή. Συγχαρητήρια σε όλα τα παιδιά για την προσπάθειά τους. Στην 10η θέση, από το ευρωπαϊκό πρότυπο Lost Scientists. Καθώς τα παιδιά ήταν από την Αθήνα, έπρεπε να αποχωρήσουν. Θα σου ευχαριστούμε πάρα πολύ για τη συμμετοχή τους. Μέχρι εδώ ήμασταν στις ομάδες που δεν κατάφεραν να μπουν στους ημιτελικούς. Όσες ομάδες κατάφεραν να μπουν στον ημιτελικό από τη θέση 9 και πάνω, στο διαγωνισμό αυτό κερδίζουν μετάλλιο. Γιατί έχει τόσα πολλά μετάλλιο ο διαγωνισμός? Γιατί αναγνωρίζει τον κόπο που κάνουν τα παιδιά όλη τη χρονιά και τη δυσκολία να καταφέρουν να ετοιμάσουν 17 προβλήματα, 17 λύσεις, να έχουν μάθει πώς να τα παρουσιάσουν, να έχουν μάθει πώς να είναι αντίπαλοι, πώς να έχει συντονιστεί όλη η ομάδα και γι' αυτό λοιπόν τους τιμάει με τόσα πολλά μετάλλια. Θα παρακαλέσω τον κύριο, ευχαριστώ πολύ τον κύριο Τσιόγκα για όλα και θα παρακαλέσω τον κύριο Σταύρο Σαμαρά από την Ένωση Ελλήνων Φυσικών να ανέβει πάνω στη σκηνή.
Λοιπόν, εγώ επειδή παρακολουθώ αυτόν τον διαγωνισμό από την πρώτη στιγμή που ο κύριος Μιχαλούδης του έδωσε σάρκα και οστά στην Θεσσαλονίκη και γενικότερα στην Ελλάδα, είμαι εντυπωσιασμένος από το επίπεδο των φετινών διαγωνιζόμενων, των φετινών ομάδων. Νομίζω ότι με λίγες βελτιώσεις μπορούμε να διεκδικήσουμε μετάλλιο. Οι ομάδες που είδα, οι 3 ομάδες που είδα σήμερα είναι και οι 3 εξαιρετικές. Δεν είδα τις υπόλοιπες, διότι δυστυχώς είχα υποχρεώσει, δεν μπορούσα τις προηγούμενες μέρες, αλλά αυτές οι 3 ομάδες που είδα σήμερα, με κάποιες βελτιώσεις, με κάποια πραγματάκια, νομίζω ότι μπορούν να πάνε πάρα πολύ καλά. Εγώ να δώσω συγχαρητήρια πάντως σε όλα τα παιδιά, όπως υπόθηκε, δηλαδή εδώ είναι πραγματικά μεγάλη δουλειά, γίνεται μια μεγάλη δουλειά, μια μεγάλη προσπάθεια και συγχαρητήρια σε όλους σας.
Ευχαριστούμε πολύ. Οπότε στην 1η θέση και χάλκινο μετάλλιο οι οικοδεσπότες μας, Φρυγανιώτης Researchers. Συγχαρητήρια. Συγχαρητήρια, παιδιά. Συγχαρητήρια. Ευχαριστούμε πολύ, κύριε Σαμαρά. Συγχαρητήρια, παιδιά, που μπορείτε να πηγαίνετε. Κυρία Παρισοπούλη, εσείς μην φεύγετε. Μείνετε μαζί μας.
Δύο πράγματα μόνο. Συγχαρητήρια σε όλους σας και ελπίζω να το διασκεδάσατε. Αν ναι, για όλο τον κόπο των παιδιών και των συναδέλφων βέβαια, ένα θερμό χειροκρότημα σε όλους σας.
Συνεχίζουμε στην 8η θέση και χάλκινο μετάλλιο. Η ομάδα από το Anatolia College, Gravity Square. Μπράβο. Συγχαρητήρια, παιδιά. Στην 7η θέση και χάλκινο μετάλλιο, η ομάδα από το Anatolia College, Fast and Curious. Συγχαρητήρια σε όλα τα παιδιά για την προσπάθειά τους. Ευχαριστούμε πολύ. Στην 6η θέση και χάλκινο μετάλλιο, η ομάδα από τα εκπαιδευτήρια Παλάδιο, Shockwave. Συγχαρητήρια και σας ευχαριστούμε πολύ. Συνεχίζουμε. 5η θέση και χάλκινο μετάλλιο. Η ομάδα από το Κολέγιο Ανατόλια, Sherlock Holmes. Αν ακούτε πολύ Κολέγιο Ανατόλια, να σας υπενθυμίσω ότι είναι 4 σχολεία και όχι 1. Ευχαριστώ. Μπράβο, παιδιά. Τέταρτη θέση και με μόνο ένα βαθμό νομίζω διαφορά από τον τελικό ή κάτι τέτοιο ή πολύ λίγο. Τέταρτη θέση λοιπόν και χάλκινο μετάλλιο, η ομάδα από τα εκπαιδευτήρια Ράπτου, Newton's 5 Low. Κάντε πίσω από τη γραμμή, παιδιά, πίσω από τη γραμμή. Πίσω από τη γραμμή για να χωράσετε στην κάμερα. Πήραν το ασημένιο πέρσι, δεν τα παίρνουν συνέχεια οι ίδιοι. Συγχαρητήρια. Και σας περιμένουμε φυσικά και του χρόνου πιο ανταγωνιστικούς. Να ευχαριστήσω και την κυρία Παρισοπούλου. Λοιπόν, απολαύσαμε όλοι μας έναν υπέροχο τελικό αγώνα. Έχουμε τα αποτελέσματα. Θα σας κρατήσω σε αγωνία, όπως καταλαβαίνετε, δεν θα προχωρήσω πολύ. Να θυμίσω λίγο κάποια διαδικαστικά για το διαγωνισμό. Αυτός ο οποίος κερδίζει τον τελικό, στο διαγωνισμό λέγεται ο απόλυτος νικητής, ο absolute winner. Κερδίζει σίγουρα το χρυσό μετάλλιο και το έπαθλο, το winner's cup όπως το ονομάζουμε, το οποίο το βλέπετε εδώ, περιμένει το ταμπελάκι το οποίο θα κολλήσει πάνω του με το όνομα της ομάδας που θα κερδίσει, για να το πάρει το σχολείο που θα κερδίσει το διαγωνισμό και να το βάλει στην τροπαιοθήκη του. Οι υπόλοιπες δύο ομάδες, δηλαδή αυτοί που θα βγουν δεύτερη και τρίτη, διεκδικούν είτε το ασημένιο αλλά είτε και το χρυσό μετάλλιο. Γιατί? Γιατί στο διαγωνισμό, όταν η διαφορά στη βαθμολογία του πρώτου από τον δεύτερο και τον τρίτο είναι μέχρι 2 βαθμούς διαφορά, θεωρούνται και οι δύο νικητές, άρα παίρνουν το χρυσό, ένας όμως είναι ο απόλυτος νικητής. Άρα λοιπόν, δεν είναι απαραίτητο οι άλλες δύο ομάδες να πάρουν το ασημένιο, μπορεί να πάρουν και το χρυσό. Στην τρίτη θέση και ασημένιο μετάλλιο κερδίζει η ομάδα από το Anatolia College, η Big Bang. Η τεχνολογία μας προδίδει, αλλά περιμένετε. Πάντα στο τελικό κάτι γίνεται στο live, πάντα. Δεν το έχω. Ασημένιο μετάλλιο λοιπόν για τα παιδιά, συγχαρητήρια παιδιά, τα καταφέρατε, μπράβο. Κύριε Βουρλιά, 2 λόγια πρώτα σας παρακαλώ.
Ο διαγωνισμός αυτός έχει ένα, θα έλεγα, μικρό μειονέκτημα, ότι υπάρχει μια μεγάλη υποκειμενικότητα στη βαθμολογία, αυτό είναι αναπόφευκτο. Ωστόσο, πρέπει να πω ότι και οι 3 ομάδες για μένα ήταν ισοδύναμες. Κάποιος, όπως είπε πολύ σωστά ο Αποστόλης, θα είναι πρώτος, κάποιος δεύτερος, κάποιος τρίτος. Εμείς κάναμε όλη η Επιτροπή ό,τι μπορούσαμε για να είμαστε δίκαιοι. Συγχαρητήρια στα σχολεία, στους διευθυντές, στους leaders, team leaders, σε όλους τους συμμετέχοντες και φυσικά στον Νονό, the godfather του διαγωνισμού, στον Αποστόλο του Μιχαλούδη. Συγχαρητήρια.
Ευχαριστούμε πολύ. Καθώς ο κύριος Βουρλιάς δίνει τα μετάλλια, να σας θυμίσω ότι αυτός ο διαγωνισμός είναι μόνο η αρχή. Ακολουθεί ο διεθνής διαγωνισμός, όπου εκεί θα αναμετρηθούμε με τις καλύτερες ομάδες από άλλες χώρες. Άρα λοιπόν σας προσκαλώ όλους σας να δείξετε το ενδιαφέρον. Βέβαια έχουμε λίγο περίεργες εποχές με τον κορονοϊό, δεν ξέρουμε αν θα γίνει διαζώσεις ή διαδικτυακά. Εγώ όμως θέλω όλες τις ομάδες, ασχέτως τις θέσεις που πήρανε, να προσπαθήσουν να τολμήσουν και να αναμετρηθούν με τις καλύτερες ομάδες του κόσμου. Συγχαρητήρια, παιδιά. Άρα λοιπόν, όπως είδαμε, στη δεύτερη θέση και μόλις με μισό βαθμό διαφορά, το ελέγξαμε 5 φορές, χρυσό μετάλλιο στην πρώτη του συμμετοχή από τα εκπαιδευτήρια Μαντουλίδη, η Λαγκράντς. Ναι. Συγχαρητήρια, παιδιά. Στην πρώτη μας συμμετοχή τα πήγαμε άψογα. Βέβαια, να πω ότι είναι η πρώτη επίσημη συμμετοχή, γιατί προσπαθήσαμε ακόμη μία φορά, αλλά δεν τα καταφέραμε να πάρουμε μέρος. Συγχαρητήρια όμως. Ευχαριστούμε πολύ τα εκπαιδευτήρια Μαντουλίδη για την συμπαράσταση και την υποστήριξη και σας περιμένουμε του χρόνου πιο δυνατούς. Το χρυσό είναι χρυσό, όπως και να είναι. Σε όλους. Α, ναι, όχι, εντάξει, τα παιδιά. Ναι, θα το διευθετήσω εγώ. Θα το διευθετήσω εγώ. Ευχαριστούμε πάρα πολύ και συγχαρητήρια. Και στην πρώτη θέση, ο απόλυτος νικητής, με τη μία, με την πρώτη συμμετοχή, από τα εκπαιδευτήρια Άξιον της Ξάνθης, η Σρέντικερ Σκάτς. Όπως κάνουν και στα κύπελα. 1, 2, 3, το σηκώνουμε. Πάμε. Το σηκώνουμε, πάμε. Συγχαρητήρια! Συγχαρητήρια.
Ευχαριστώ.
Ανθίσου να καλή προσθήκη, δεν μπορώ να πω. Ήρθες και δίδαξες. Μπράβο, Κορίνα. Sorry, το έβαλα ανάποδα, γύρνα το. Μπράβο σου.
Ευχαριστούμε.
Νίκο, κανόνισε του χρόνου να έρθεις.
Εγώ μπορώ να πω κάτι. Μπορώ να πηγάσω μικρόφωνο. Για την ομάδα.
Νάνση, ως κάπτεν της νικήτριας ομάδας, θα μας πεις 2 λόγια για την εμπειρία σου.
Ναι, να σας πω. Βασικά είναι ένα... λοιπόν, είναι ένας από τους καλύτερους διαγωνισμούς που έχω συμμετάσχει, γιατί ουσιαστικά απαιτεί την ομαδικότητα, απαιτεί την διαρκή προσπάθεια εδώ και μήνες για να επιλύσουμε αυτά τα προβλήματα και να έχουμε μια αξιοπρεπή παρουσία. Χάρηκα πάρα πολύ που σας γνώρισα όλους, ήσασταν όλοι εξαιρετικοί. Και ευχαριστώ φυσικά την ομάδα μου, τους καθηγητές μου, τα πάντα, για την επίδοσή μας. Είναι όλα λόγω αυτών. Ευχαριστώ πολύ.
Ευχαριστούμε πολύ και συγχαρητήρια. Ο υπέροχος αυτός διαγωνισμός έφτασε στο τέλος του. Εγώ να σας ευχαριστήσω όλους. Ανανεώνουμε το ραντεβού μας, τόσο για τον διεθνή διαγωνισμό το καλοκαίρι και μετά, αλλά και για του χρόνου. Ξέρετε ότι οι ομάδες ξεκινάνε και προετοιμάζονται ήδη από το Σεπτέμβριο. Άρα λοιπόν δεν τελειώνουμε εδώ, ανανεβώνουμε το ραντεβού μας. Θέλω να ευχαριστήσω τα εκπαιδευτήρια Φρυγανιώτη που μας άνοιξαν τις πόρτες τους. Τον κύριο Σάκη Φρυγανιώτη δεν είναι εδώ σήμερα, τον υπερευχαριστώ. Είναι ένας εξαιρετικός άνθρωπος. Θέλω να ευχαριστήσω όλους εδώ πέρα οι οποίοι μας βοήθησαν και τα είχαν όλα έτοιμα και άψογα. Θέλω να ευχαριστήσω όλα τα σχολεία τα οποία συμμετέχουν στο διαγωνισμό, τον πιστεύουν και τον αγκάλιασαν. Θέλω να ευχαριστήσω όλους τους μαθητές οι οποίοι με πολύ κόπο έρχονται και πραγματικά κουράζονται για να φτάσουν εδώ που τους είδατε σήμερα. Θέλω να ευχαριστήσω όλους τους καθηγητές. Είναι σε διακοπές, θα μπορούσαν αυτή τη στιγμή να είναι με τις παντόβλες στο σπίτι τους και όμως ήρθαν εδώ πέρα να μας τιμήσουν. Θέλω να ευχαριστήσω και όλους τους βοηθούς μου, όλους τους εθελοντές. Θέλω να ευχαριστήσω και τη γυναίκα μου για την τριήμερη άδεια που μου έδωσε. Να είστε καλά!